It's the Chinese plugin that I use that does dual streaming. It does co-streaming. I could have 5 different streams go up. I could go up on Facebook right now. I just don't like any of those platforms. I really like Twitch. What's up, Cyberdunk? That was, yeah, 112. Okay, so those just now. 1 viewer, and it's Cyberdunk. YouTube chat. So YouTube, Autobother VOD. Go to the modular synth thing that I have going on. And then go wait till chat loads and then pop it out. At some point, maybe soon, I'm going, yeah, happy Friday. I am going to break down this thing. The rack with all the equipment in it. Because it needs to be reorganized. I need to get this sound card, the Focusrite out of there and over to the other bench. And I need to, I don't know, probably redo some of this stuff, some of the network stuff, and just have a time of the whole thing. Clean all the dust out and then redo the water. But it's a kind of weighing on me pretty heavy. Maybe I shouldn't do that this weekend. I have other stuff that I really need to kind of get to. Although I'll end up doing nothing. That would be the worst case scenario. I don't know. I'm thinking about it. It's a lot of work. It was a lot of work getting that thing together. It basically houses all my stuff. And I tried, at least tried, I didn't really succeed to make it modular. I tried to make it, well, not necessarily modular. I tried to make that rack itself be like its own standalone product. So all the computers in it go to keyway connectors that have, you know, a plug on the outside of the thing. So I'm plugging into the rack itself instead of plugging into the machine on the rack. I think it causes some signal issues, though, with the longer cables that I use for all the cameras. Need to break down my rack as well, but it's such a hassle. Yeah, I got to break this thing down to its bones and then put it all back together because all those computers need to be dusted. There's 2 computers in the rack, and they've both been sucking up all of my dust particles for years. It's been a couple years with this rack the way it is. Hey, lines and squares. I decided there was enough to do with this still because we got to get into like the programming of it, and we got to put it up on the module tester and get it all tuned up. So we're gonna do this today instead of doing this and the CAD stuff. Maybe I'll start the CAD stuff on my own without you guys. I hate to do that, but and then that can lead us into a sponsor stream where it's not just starting from scratch. I actually have all of my ducks in a row, so to speak. Yeah, the only thing is, like, my version of Fusion 360 is paid. It's not the free version, so there may be some things that the paid version has to deal with that I don't. And just from executive dysfunction, I want to reprint this car body in the smoked whatever it is, SLA goop. I mixed black with clear, and it actually has a pretty good smoked tint to it. So if I print it, then the windows will remain clear, and I can maybe mask them and then paint the rest of the car body a color, and it'll be see-through windows. And at some point, maybe we'll just do it manually instead of designing it in CAD. I can sand out the backs of these so that they're open, or just drill them, and then we can put LEDs behind the lights. That would be very fun. You know, if I mask off the lights like these, those can remain clear, and we can put like a little LED, little surface mount LED behind them. This is an Atom SZ2. It's a pretty neat 1/24th scale RC car that I put together for, like, basically I wanted a drift car for the pandemic. It was a little bit post-pandemic that I decided to buy this because my 3D model of a 1/24th scale RC car eventually fell apart due to all the inaccuracies that were in it. There were just stacks of inaccuracies that led me to just kind of freak out and go, you know what? I'm just going to buy something and build it so that I don't have to deal with all the hassle. And then I ended up modeling the electronics cross beam. There's a beam across the top so that your car doesn't taco when you super accelerate, even though this has a pretty thick aluminum base. If you have a flimsier base than this, the RC car can tend to like bow in the middle. So they put a brace up top, and I took advantage of that and printed it in PETG, and then have the motor controller, gyro, and the radio. It's too bad the motor controller couldn't be a little smaller. Yeah, I worked on this for a long time. It was a lot of work. getting the mesh even the low poly mesh of the car in, and finding a car that would actually fit the wheelbase of this thing was very difficult. But it taught me a little bit of CAD, hopefully enough to be dangerous. These little magnet connectors are the best though. So I have 6 pins that I can use to control stuff with. So it'd be like ground, and then low beams, high beams. So that's 3 pins already, right? I've already used up one of the connectors. And then brakes. And then I've got, what was that? 4 pins. So I've got 2 pins left. So I could do right turn signal and left turn signal, or I could do reverse lights. Reverse lights would be kind of cute, but I don't know. I don't know what I would do. Fogs. Horn. Beep, 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 beep. A horn can be put in the base. That doesn't have to be on the outside body. And then the first thing this thing will do as soon as it meets the curb is explode. Like the plastic will just shear and it'll explode. I've done it before. So these are disposable car bodies. It's like a 4-hour print. But all of the extra stuff that I do, I want to keep to a minimum, because then I'll care about it too much. And the last thing I want to do is care about it. That's why I want to build a generative RC car base. I think that would be hilarious, because the first time it crashes, it'll just splinter into a million pieces, but it'll not weigh anything, because it'll be a big spider web. That would be neato. I don't know. These are just ideas that rattle around in my head all the time. Actually doing this stuff takes a lot of effort. So maybe at some point I'll feel like putting the effort in, but I need to clean up around here first. And so doing the rack is kind of part of that, because it's kind of gotten a little bit messy over there, especially with the mixer sitting over there. I can put in the drawer that Julian gave me, the rack drawer, and put the mixer on that, and that'll kind of pack that in for everything. Although that mixer is also nomadic. It moves over to the gaming computer if I ever decide to do a gaming stream again, which I haven't done. I haven't done it. I haven't done a gaming stream in years. I've pivoted over to the actual building stuff and not having a schism in the content on this channel. Start up a separate gaming channel that'll probably be more profitable than, than all the stuff that I do here. This is a yacht rock mix. This is something that one of the DJs at what is it? Space Cowboys does. It's 8-ball at Space Cowboys, and it's Don't Stop the Yacht ... rock. It's a keyed, coined genre fairly well a couple of years ago, many years ago. It's the type of music that you listen to on your yacht. There are enough gaming channels out there? Yeah, but what if there was one more? What if there was one more? Yeah, that's why I'm not really in a super rush to go back to doing the gaming, but I do have that microphone that's pretty expensive, and I'd like to take advantage of it. I'm sorry about the burping. I wolfed down a roast beef special, roast beef sandwich before starting stream. People were delayed, and that's what delayed stream is, getting some food in my body. I need to put food in my body before stream, because otherwise it's too much of a stint fasting. And if I fast for too long, I can go diabetic ketoacidosis without even getting high blood sugar, because the drugs that I'm taking are powerful and they stifle all kinds of different signals to keep my glucose levels really good. But if I'm not careful, that'll lead to less basal insulin in my body, and if you don't have enough insulin in your body, you can go diabetic ketoacidosis. So I gotta watch it. I gotta eat something every now and then so that I don't full bore go into fasting mode. So I wolfed down a sandwich. I should have been part of a sandwich. It was a whole one. I'll be better about that in the future. Urgent alarm. Pump unreachable. From when? 17 hours ago. That's not a relevant message. Put my phone down. I need fuel for the stream. I really don't. You've seen how much of a beach ball body I have. That is a lot of energy. That's a lot of potential energy that my body can use. I could probably fast for a month on my own 100 or so pounds of body fat. And I would love to do that. I would love to have it scooped out of me and put into like a car fuel thing and see how far across the country I could get burning my own excess of fat. How much energy has my stupid body decided to store just in case? Oh, it looks like you're running from a wildebeest. We better store more fat. I was like, stop it, body. Stop it. Stop doing this. The UV light away, put some of these tools away. I don't think we're gonna need hot glue on this. I was afraid that we were gonna need hot glue on it, so I got the hot glue gun out, but this is a cheapo 24 volt hot glue gun. It's for tool guys, so it looks like a tool that a tool guy has instead of like a dinky little hot glue gun. I kind of wish it was a dinky little hot glue gun, but I bought it because it was cheap. It works all right. Put that back in the drawer. Goes in one of the bottom drawers. What was that? So there was a streamer that rated me way back in the day when I was doing a game stream, I think. And what do they say? They were saying, "Bless the rains down in Africa," and I quoted the opposite, that other song. This is the only one I can remember though right now. Oh, the Vegemite sandwich, Land Down Under. That's right. They were like, "I bless the rains in Africa." I'm like, "Oh, that's that song about the land down under. Women roam and plunder. Can't you see the thunder?" They really pissed him off. It was great. Bam, bam, bam. There's no telling if that song is in this mix. It might be. It's for the professionals. Yeah, and so your tools look like your other tools, and so you don't embarrass yourself out there on the notoriously fashion-conscious tool guy circuit. This can go away. We're gonna do LEDs soon. We'll do LEDs soon. LEDs are much better for stream because they're flashy and cool and you can do neat stuff. Hopefully I can find some good code for it. Oh, another thing that I want to check out. I'm very distractible today. Hold on. Let's I'm gonna make room for this tester to just be in the background. That could work. Let me get out my modular tester. Oh, my eyes! What have you done? Bow, 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 bow. All right, so let's see. Node red, true NAS, HD status, node status. No, that's burps. Not Facebook. No, 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 no. This is all, I'm not using the right language, I think. Captain Tape is on the table. I feel safe. Captain Tape is a wonderful product. Polyamide, if you want to go with generic brand, but at least the stuff that is generally considered to be Captain Tape, because it's like Band-Aid, right? It's an adhesive medical strip. Captain, the sort of blanket term for a bunch of different things, is really nice because it doesn't leave any residue behind. Polyamide, of course, can be used in all kinds of different applications, but it's a good general purpose sticky tape that kind of just holds things together. And if you need insulation on something like an electronics part that's going to go on a board and you need to insulate because there's board damage or something like that, it's a pretty good thing. I mean, in here, in an indoor environment where it's generally around 70 something degrees, it does a really good job. But it's not, you know, use the right tape for the right job, obviously. But it's good because it's very available and cheap, and you can just throw it at stuff. You use it a lot in solder reworking. I need to get 2 little wires for the MIDI thing. the MIDI output. 2 little wires. Where do I have 2 little wires? I'm looking around to see if there's... I guess we could use wire scraps. Let us get scraps. I had a big... Oh yeah, here's a big flat cable that we scrapped earlier. We could just use these. I mean, like, you know, all the stuff that the beginners electronics things will do is use like big wires for stuff like MIDI, and MIDI is just not, it does not garner big wires. Like this will be fine for the types of current that MIDI is outputting, because it's just a digital signal protocol, right? I think I need to do a BRB before stream. Yeah, well, I need to do a quick BRB. So let me do a BRB. I'm going to leave this up. We got plenty of time, and I'm not going to take that long. So let me check here. Oh, yeah, we got plenty of time. All right, let's put up a BRB. Now, can I do this from here? I think I need to fix all the overlays on the Stream Deck, so I don't know if that'll work. BRB. Nope, it doesn't work. It's put up a little caution flag, so I need to actually go to studio mode. I need to go to overlays, and I need to put up BRB2. Oh, where is it? There it is. Hue, go up. And then, where is my... Well, that file moved. Okay, let's see. Oh, the forklift's gone too. Does pee pee poo poo work? It doesn't. Okay, all right. We'll just leave the BRB up then. Oh, wait a minute. I think I saw it. Yeah, there he is. Why are they going so fast? The scene is unburdened, and so it's too quick. Could you get away with using thin motor wiring insulated wires? I'm sure you could. I don't know how thin you could go with MIDI. How much current? I mean, you're basically lighting up an infrared LED. That's what you're doing with MIDI. So it doesn't require a lot. The infrared LEDs are very eager to create light. But okay, I'm going to BRB. One sec. Back, quick biological curveball. Okay, so let's get this out of here. Well, that works. It works from this screen, huh? We gotta get pee pee poo poo out of here. What are you doing here, pee pee poo poo? I need you gone. Frameless overlay, and then we can get rid of this one. Boop. Got to do that manually until I can go through my Stream Deck and fix everything, which I could do now, but I won't. But I won't. All right, so we set up YouTube, and I've got that all set up. We got Twitch going. I got that all set up. We got the stream starting soon up there. I can get rid of that. And then we can get to actually working with this MIDI controller, because I think there's going to be tuning involved in it, and I think it's digitally because there's like a program button on the front. So there's probably a way to get it into like a tweaking mode, because right now, well, let me just get this out of here. Boop. Okay, and then get the music out of here. I like this mix, but we're done. I'm just gonna pause it. It's too fancy. Fade outs are too fancy, and boy, I could automate a lot of this stuff. You know, I could have it fade out the music and you know, do all kinds of cool stuff like that. Because my setup is hooked up to Node-RED, and I could use Node-RED in order to sort of direct a lot of these different scene things that go on. Eventually we'll get there. It is an arduous process of me learning how to program while on camera, which is daunting, but I've done it before. It's the whole reason I know how to program Python, is that I actually had chat helping me with it. And this was during the pandemic, so people were around and a little bit more charitable towards actually humoring my bullshit. And that was pre-Burn the Subs. I learned Python for Burn the Subs. We will get back to Burn the Subs. I promise you that we will work on it a little bit. Go Lurk. Yeah, okay, go Lurk. Thank you for popping in during the beginning of stream, at least before I had to poop. But now I'm all better. I probably have stink lines and flies coming off of me right now, but I washed my hands with soap. Anyway, we need a little tiny wire, and we need to get the MIDI thing working, and we need to learn how the MIDI thing works. So we're going to work on that today. That's going to be probably the entire stream. I shouldn't kid myself. I thought, well, we could do that, and then we can plan out my wall-mounted computer over here using Fusion 360, and it could be a sponsored stream. That has to be its own stream. That has to be its own stream, and it's going to get in the way of Burn the Subs, but it's something that I desperately want to do because I'm trying to clean up around here, and the best way that I figure I can clean up around here is by moving stuff up the walls. I don't have space anywhere else but on the walls. And since my LAN party, I bought a mobile PC specifically for Linux gaming to test it out, and now I don't have to schlep my entire setup to a LAN party anymore. And the water cooling computer is a little bit heavy, so I figure I could put it all on a derelict wall control thing, and then I could put it in here. I'd show you guys. Go to the Discord where I posted a picture. So the space that it'll go in is currently a little disorganized. How do I open the link? There we go. Oh my God, it's too big. The camera's too high quality. This is the corner of my gaming desk. You can see this is where I had that massive amount of paperwork. This is the tube amp that I use for headphones. These are monitor cables that I've yet to install now that we figured out that my computer resetting when I get up is caused by static electricity and bad DVI cables or bad DisplayPort cables, which is crazy. There's ever-present bottles of insulin everywhere, and I've got my Omnipod current stash, as well as the Flipper Zero and the Onagachi that I have not messed with. I have an extremely expensive pair of headphones that I got on super sale many years ago with a friend of mine. We both put in multiple hundreds of dollars for these things, and these are, if you see people with the Barodynamics that are metal on the outside, they spent a lot of money on those. But I did it to complement my Trump era tube amp, because Trump sent the $600 checks to everybody. And I said, I want to commemorate this, and I want to actually do something that I might regret. And so I got the slightly more expensive shit audio tube amp. And then I had to get tube spacers so it didn't overheat. I think it was a good purchase, actually, to be honest. It's a lot of money, but yeah. And then we've got a copy of Space Cop, which will eventually become a rare artifact to the next generation of weirdos like me. Anyway, so this corner has just a big acoustic panel. And I say acoustic panel, but they don't do much. Believe me, I know. They don't do much. If you're really looking to quiet your room down, the best thing you can do is get the acoustic foam that goes in the corners. The corners are what's going to give your room the most like resonant echo. Bookshelves are also a godsend when it comes to audio. A room with enough bookshelf in it will sound like you are in the middle of a field with nothing around you, right? And that's kind of what you want from your audio. You want a little tiny bit of resonance, or else it sounds weird. But then if it sounds like you are in the middle of a room, of a quiet room that's pretty big, that's like perfect, right? For like voice acting and those kinds of things. So the acoustic panels that I put up should help with that, but not really. These little dinky ones, nah, you need bigger triangles on them in order to kill most resonance. Now, I'm also surrounded by trash, and the trash absorbs a lot of the audio waves, so that's why I have pretty good intrinsic audio on this channel. I also use the lav mic, which kind of focuses on the front of my body, and I don't know. It's a whole bunch of stuff combined is why I get good audio, but don't think that these acoustic panels are doing a whole lot of lifting here. They're not. That's the point of what I was saying. But anyway, this little corner, and the dog towel is actually sitting on a stand. It's like the stand that I've got back here holding up the laptop. That's for the mixer. That's why I say my mixer is a little bit nomadic. I kind of move it over here when I do game streaming or voice chats. I haven't done a voice chat in a long time. I got to an age where nobody wants to voice chat anymore, including me. But yeah, so that's my sort of private little computer setup over here. And there's a Kinect in the corner, which would be hilarious to get going for a game stream, so that my avatar would just be a 3D point cloud of me sitting there. It can do that. You got to go through some like old software in order to put that all together. But yeah, the dog towel's just sitting there to keep it from getting dusty. But that's where the mixer would go. I'd float it right over there. But I mean, that's like visually, there's a lot of stuff going on here, but it would also be neat if there was a computer sitting in the background. So this is about the size of that wall control panel. It means things might be a little bit more echoey in that area, but I don't know. I think I'd rather use that space to put the computer there, because right now it's taking up the other side of the desk and kind of fouling things up. But the best way to do that is doing it through CAD, and that'll be an entire stream. That won't be a second part of today. I'm not like Rabaz. I can't do 8 to 10 hours a stream. In the future, if the current political nonsense, the ennui factory that is current politics, gets to where they want to go with healthcare and health assistance programs, I may have to take on 20 hours a week. Twitch hopefully counts. Hey, Poopsie Doodle. That's funny. Poopsie Doodle I've got on my chat thing with bye, and then down a little bit further down it says hi. So I'd pick up a Wednesday stream, and that would give me a 20-hour week, I guess, that I could prove. Did you let the smoke out of the thingy from yesterday? No, we're going to finish that up today. That's what we're going to do today. If push comes to shove, I will do Wednesdays, and it'll be a marathon, Tuesday, Wednesday, Thursday, Friday streaming. And then I can do 5-hour streams, and we'll 5, 10, 15, 20, right? That's the plan if things go weird. I don't know if I need to start doing that now, because it's when you prove out the healthcare stuff, you're proving it out for the previous cycle. I don't know how that's going to work. Hopefully they build something in, because it's like, yeah, I got to change my schedule. There's always stuff to work on. There's never nothing to work on here. So I'll be able to meet those requirements and not actually get fucking killed by healthcare nonsense, hopefully. Yeah. Isn't life grand? Isn't life grand? Okay, so back to what we were doing. We were finishing up this build, this Erica Synth's MIDI to CV converter. The MIDI to CV converter is something that I want to have in the modular synthesizer, because that turns it into more of what you would expect from something you would call a synthesizer. So you hit a key, it makes a tone, and it manipulates that tone however you configure the synthesizer. 69-hour stream. I've doing a marathon, like a programming marathon or like a building something marathon, maybe, but the things that I need to rebuild in here, I guess the milling machine, but that's going to be a whole ordeal in and of itself. I need clear desk space in order to embark on that. I do want to do that because the milling machine is partially out of commission. It's basically a drill press right now without the DRO working. So that's another thing that I got to go through. And it might be that the way that I lash down all of the wires and stuff are causing it to bend a little bit more in one area, and that might have done like a mid-break in a wire. And that's tough to troubleshoot. That's a tough thing to troubleshoot. So we're gonna have to get out our magnifying glass and like really go through the mill. And while we're at it, I've never re-greased anything in that mill. So taking the grease off, wiping it all down, cleaning it, putting the grease back on and putting it all back together and adjusting it so there's very little backlash is a thing that I could do by time. So it's a thing that I would like to do if tables are clear, and tables are very not clear. Part of clearing the tables involves getting the synthesizer working so that I can start putting modules into the rack and have a thing. Yeah, that's the plan anyway. So Erica Synth's MIDI converter, we need to pull up the data on it. We did download the entire project, so I think maybe we'll just get at it from there. I'll get rid of some of these pages, all the reference material that we were putting up in order to make informed substitutions of parts. And we don't need these examples, and there's the Node-RED stuff. Okay, so let's go to the downloads folder. Oh, it's right here. Controls, firmware, and main. Main is bill of material, fab reference. Oh, that's just for, okay. DA4, DA5, that's all that stuff. We need like the guide. We need the building guide. That's just the fab stuff, okay. I can't believe I put the headers on the wrong side. Assembly, there we go. That's what we want. If you're reading this, most probably I am dead. I mean, you're about to build an Erica Synth's DIY MIDI CV module. This module is 35 millimeters deep, skiff friendly, has a solid mechanical construction, and doesn't require wiring. Doesn't require... Erica Synth's black MIDI to CV is compact, highly accurate, and easy to use duophonic MIDI interface. It emulates a classical monophonic and duophonic synth behavior, as well as can be configured for use in 2 independent MIDI channels. Geez, that was an awkward sentence. Bonus features, MIDI clock output, and analog glide circuit on both channels. The glide circuit is literally just changing the transfer function for the op amps. That's all it's doing. It does both at the same time. They call it a feature, but it's because they used a dual pot. Wonder how much that little module costs? I think it's like $139 for the extensive kit where they give you all the parts. It was $20, $30 really, kind of $40 with shipping for just the circuit board and the microcontroller. And then an already assembled one, I don't know, Erica Synth's MIDI CV2 shopping. $119.99 pre-owned. And then that's not the right thing. Not the right thing, not the right thing. Yeah, I guess I could build it up and sell it for 120 bucks, although nobody's probably buying. Pittsburgh Modular, $111. $111! That's got a tube. That's cute. Fusion delay flanger. That looks cool. How much is that? $359. Okay, I'm closing this. Jeez, these things they're just numbers that you quote. Where are people getting all this money? They must be like holding people up in back alleyways or something. I use one of these to do everything that does Mini Plus. MPK Mini Plus from Akai. Is that what that guy's name is? Oh, this thing. Look at that. Yeah, I looked up like a more modern MIDI keyboard, and they were ridiculously expensive. Like ridiculously expensive. I do like how it's got the pads on it though. On sale from Sweetwater. How much are they? 140 bucks? Yeah, I was looking for something in like normal like plastic toy range of price, and the ones that I was finding were like $75 for like just this little tiny keyboardy thing. And I think they have the TRS jack on the back, and you can get an adapter cable for that. So in the future, I would like to make it lighter. For now, I bought a keyboard on eBay, and it's a big plastic piece of shit. We took it apart the other day. I've used those keyboards like that before for the Fire Cannon MIDI controller. By all means, I should be making this thing myself and producing it as more of a piece of scientific equipment if I'm going to be using it to operate my my setup. But still, we'll just go forward with this. So anyway, let's look at the assembly guide here and see what we forgot to do. We put the jumper in there and everything. I remembered that. This is the negative lug. Yes, indeed. I did forget to put it on the right way around. Okay, so we need to solder to the MIDI connector, and ours does not have solder cups. The luxury of having solder cups on the MIDI connector. We just have pins sticking out, so we'll just put a couple wires on that. So let's do that right now. Walking through the park and reminiscing. So the legs that we want are these two. What numbers are those? 5 and 2. Let's see what they say. Did they say 5 and 2? They just have a picture. Place LEDs in relevant places. Cut off their pins. Also, this is a separate step. That should be step 9. What? This is a little note at the end. Solder the MIDI connector wires into the relevant holes. Into the relevant holes? Tell me which ones they are. Oh, man. What a bunch of piss. This is not... I don't think this was written by professionals. All right, so, I mean, it's going to be... Oh, it's these two. Yeah, that's right. Skip in the middle. So it's actually 4 and 5. So let's double check on that. MIDI pin out. MIDI pin out. MIDI pin out. I'm MIDI pin out over here. MIDI tutorial. Here's a bunch. I love how these are in there for redundancy and they're just not used. Although we're soldering the 2, is that going to rely on... It doesn't rely on the PCB itself. How? Wait a minute. Oh, one's ground and the other's signal. Okay. Or they're just signal and signal into the LED. It's fully isolated. That's right. At the end of step 7, it says 4 and 5. Oh, wires to lug 4 and 5. I see. Okay, so lugs 4 and 5. Cool. Just, I got to double check on everything, and reading is not our strong suit. What are the identities of pins 4 and 5? So I can inform which one gets the stripe. So pin 5 is positive, so pin 5 will get the stripe. And then what are we up against over here? I have to get in there to solder, but we didn't put the standoff in. So I can just remove this. Get my vise. Where's my vise? There it is. I'm a Twitch streamer. You think I can read? That's where you're wrong, bucko. I don't even know how to read. Oh, and they're labeled MIDI 4 and MIDI 5. Oh, that's nice. That's nice of them. What up, 3D lasers? So these don't get a ground because MIDI is this weird protocol where you're basically just lighting up an LED. So they're both floating contacts, and I guess that isolates out your foreign signal from hurting your machine, which is a weird way to do stuff, but that's apparently how MIDI works. So we're going to use some of that IDC cable that I discarded, that I shortened for the Raspberry Pi stuff, and I can just put that right here. They should probably be separate wires, to be honest. If I do those two there, I could even... you know what? I'm actually going to use the solid core wire, because that's going to go in so elegantly, and I don't think I'll ever have to remove it, that I don't need a stranded wire in here. Although this might flex around, I'm going to try to keep it low to the board so that it doesn't get knocked into if you put this thing down on a table. So instead, I'm just going to use this big piece of Where'd it go? There's a big scrap. There's a big scrap piece just sitting here. Speaking of vices, I'm gonna go get more coffee. I want coffee. I want coffee. I don't got no coffee. All right, let's just use this black wire. It doesn't matter. This is such a short jump for the wire to make that we can just go right over to where we need to be. Nice and easy. So let me just lay down some solder to start. To turn the iron on. So we're finishing this thing up, and I'm not kidding myself in thinking that we're going to do a second project today, because I think all of my effort is going to be spent on this thing and learning it and getting it running. Tin this as well. This is tinning the contacts. It makes it much easier to work with. I could probably cut the ones that aren't used. I don't know. Let's just keep it unaltered. Cut them short so that they don't knock into something and then hit each other. Nah. I could even put a little piece of circuit board right there. That would be the best way to do it, is solder this into a circuit board. Of course, then if you want to pull this thing apart, you have to pull the whole thing apart. You have to desolder stuff, so nah. Well, you still have to desolder stuff to pull this apart, but you know, I need the microscope for this. I can't see what I'm doing. Gotta love asynchronous serial communication. I was at a Crystal Method, or was it Chemical Brothers? It might have been Chemical. It was, I think, Chemical Brothers and Orbital show. And the Chemical Brothers had this huge array of lights that they were performing in front of. And they had all their synthesizer stuff out. And at one point, one of the notes got stuck, because MIDI is just that reliable. One of the notes got stuck, and it was just playing this singular solid note for an extended amount of time. It's nice because, you know, it's not pre-recorded, but what happened was they pumped a bunch of smoke to that side of the stage, and a boffin came out dressed all in black and was plugging and unplugging and restarting the synthesizer to try to get it to stop playing the singular note. It eventually stopped, but it was like, just because the MIDI messages got messed up and a note stuck. So the protocol is not as good as it could be. It's very old, and it's full of holes like the rest of us. Walking through the park and reminiscing. Okay, there we go. Nice and soldered to that giant pad that they gave us. I got these tweezers. I don't know how good they're going to be. I think I can use them to strip wires like this. I can definitely use them to cut wires like this, although I don't know how much that damages the stuff. But these might clean up my method of using wire wrap wires quite a bit. So let's straighten these out. I'll get the tweezers over here. Straighten these out and see if I can strip the ends of the wires cleanly with the pair of tweezers without totally ripping them out. If I pull too hard on these, it'll strip the entire wire. I just need it to be the end there. So if I just go at this and do a doot, and pull. No, that didn't really work. Sort of worked, not really. I still don't know how hard to pinch. I'm risking breaking the wire when I do that. If I move it down a little bit, I can pinch off less. Oops, that didn't work. There. That did okay. I'll just twist it upwards. And then when I go to solder it, the jacket is going to pull back a little bit. How far did I go on this one? Probably not far enough. I need to go a little further on that. Actually, you know what? No, that's fine. I'm not leaving extra wire for me to like mess with it later. You know, like if I have to pull the MIDI socket out or anything, I'm not really Not really planning on that contingency. Try to get a close view over here. Hard to see all this stuff because of the way that I've got everything set up. Wrong one. This one. There we go. I'm using the OBS output as a second set of eyes, although this is actually a little bit more detrimental to my positioning this wire than I thought. All right, I gotta tin the ends of these so that they'll solder up quickly because it's hard to see them. Oops. Yeah, I need to use the magnifying headgear. Tin the ends of this. Get in there with the solder. What the? Windows update again? Snooze. God, this and the Android update. The Android update was like, you have to restart, your machine's gonna get hacked. I'm like, look, the last time I did this, it almost broke my insulin pump. Luckily, Android 16 went through just fine. At some point, I'll have to recompile AAPS, and I am scared about what Google is planning for Android in the future with their side-loading prevention. What do I have to do? Do I have to register as a developer in order to be able to load the Android pancreas system in there? They essentially are breaking my insulin pump with this. They are grabbing it from me and smashing it on the ground. And so I really hope that cooler heads prevail at Google and they decide not to do this, because it will be an absolute shit show for both people like me and researchers and all kinds of other places that rely on side loading of apps. Especially some companies do this. You know, the tracking device unit that I used to work for did it. We all side load our custom applications onto these phones. That's the whole purpose of going with Android over Apple, is that it is essentially a pocket computer. But they are ruining it because they believe it is a pocket advertisement device. And they want to make sure that they can serve you ads at all times, because that's what they do. And got a little dollop over here. No, this is an old Windows update. This one has been asking me to do this for months, I think. The update from last week started killing SSDs after any file transfer of 5 gigabytes or larger. What the fuck? Yeah, you know, I heard about that. I didn't know the details of it. And I haven't applied the Windows update or done big file transfers. The SSD on this machine, I do big file transfer to get the data from my recorded streams over to. I'm going to do that now before this thing updates in the middle of the night at me. That would be recording on the desktop. Where is it? I'm hitting the R key. Oh, it's right there. Yeah, let's, oh boy, that's a lot. 2 of these don't transfer. It's the 04 and 05 doesn't like to transfer. So all of you but today. No, what's the date today? 08/29. So all of that, and then not these at the bottom. Cut. And then we're putting it into stream storage. Paste. All right, I'm gonna have the computer working on that in the background. The one from 8/13. Yeah, I think this is the one from 8/13 that it's trying to apply. I don't think, hopefully this doesn't kill my SSD, otherwise it's killing my stream computer, and then I will not be able to stream. Although that would kick off an entire episode of me taking apart the entire rack mount thing, getting a new an old SSD from the shelf, and reformatting this entire drive, going Linux maybe? Maybe not. I don't know. Maybe I'd have to buy a copy of Windows 11. Is there some slimy way to get a copy of Windows 11 like with Windows 10? I guess you can get Windows 10 and then go through the upgrade process. I don't know if this has verified hardware module stuff in it. Oh, that's the wrong focus. Uh-oh. I'm out of focus. Ah! Oh my God. Okay, I'm back. Yeah, I'm, by the way, I am 1 hard drive or 2 hard drives failing from having a complete meltdown and my stream not going live for a month. Some streamers are on a complete house of cards. Plenty of activation scripts on GitHub, which is ironic. Microsoft GitHub. You got to be sure to put the copyright in there. Also, what's up, Bovanet? How you doing? Okay, so we got the MIDI connector connected. I think that might be the last thing. We got the button. All the parts are on here. I would like to figure out whether or not this thing has a tuning procedure on it, because I want it to be that accurate. I do want it to be that accurate, and I don't want to use glide in order to get the voltages into the right spot. Having this thing digitally tuned would be good. I'm still thinking about, like, what if I use the low profile standoffs here instead of the no, leave it alone. It's just weird that there's like a bomber bay in the middle of this thing. You can support the scammer money laundering infrastructure and buy Windows Key from a CD Key website for like $5. Yeah, I did that with some of my copies of Windows whatever, and it's just because of the way they're sold, I guess. I don't know. There's like an EU law that enables them to do this, the $5 keys. For the most part, I haven't been burned, but I mean, if you're spending $5 on a Windows key and they burn you, it's like, okay, you know, it's like, all right, fine. You win this time. It's just not worth the trouble. Yeah, and then you get the installer direct from Microsoft. So, I mean, if anything happens to this hard drive, I'm saying this now because apparently what I'm doing is extremely risky with the latest Windows update, which is, that's the straw that broke the camel's back. If Windows ends up blowing up one of my hard drives, I'm mad enough that I would maybe perhaps go to Linux as a result. There's a lot of stuff on this hard drive that I hope it doesn't kill. The file server is supposed to prevent something like that from happening, but since Windows SMB shares are a little bit hinky in how they operate, they kind of like, because it was open for so long, apparently it like sticks in the computer, which is weird. Accessing the file server from this machine, I can't write anything. So if your current OS is legitimate, the Activation E is baked into Europe, and you can just install 11 from scratch and it should just activate fine. Huh. If the BIOS is not, okay. I don't know what my key is. Yeah, I don't know what my key is. It might be an OEM key. It may have come from anywhere. But I guess that's how I smarm my way into Windows 11. Do you have to have trusted hardware platform stuff in order to run Windows 11 at all? Probably do, right? I hated that stuff. And I do have a Microsoft login, but it's not registered on any of these computers. Working on migrating most of my machines to Linux. It seems like the way to go, right? You can use Rufus to remove all the requirements. Interesting. You guys, I got a slimy crowd of Windows weirdos. It's great. You guys know all the workarounds, all the slimy little workarounds in order to get our stupid little selves on Windows 11 without having to go through the song and dance that is typically required. I hate that song and dance. I will not have a login, Microsoft. This is my computer. I own it. It requires trusted platform unless you use these programs. They call them programs, and they do stuff with your computer. You guys ever hear these things? They're called programs. Some call them applications. Yeah, so we've got the MIDI thing built. If you're not familiar with this, you're not familiar with my channel. That's fine. This is a tester for modular synthesizer modules. What I've done is I've taken the 3 voltages that go into modular synthesizers. 5 volts is typically not really used, 12 volts and minus 12 volts, and I've got a 100 milliamp, actually 500 milliamps, half an amp range on both of these. This should probably be a 100 milliamp because negative 12 is really only used as like reference in these machines. Mostly everything is relying on plus 12 volts to make the 5 volts or 3 volts that all the modern electronics relies on. So what I've done is in the base of this unit, I've got all of my power supplies, and the way that I do modular synthesizers is a little bit overkill because I know my electronic test equipment and stuff. So what I have are modules from a company called Pololu. Pololu is a robotics stuff company. So instead of sifting through the grand pantheon of AliExpress parts and whatnot else, they have the stuff that they know works on their website. It's a lot like SparkFun or what was the other one? Anyway, one of those specialty electronics places. You don't have to sift through so much. You're paying a little bit more of a premium, but their voltage regulators are so good. They can handle tons and tons of amperages. So I've got like 5 amps of 12 volts and like 2 amps of negative. The negative 12 volt just came from random eBay looking up for a board. I've got a 15 volt barrel plug on the side, and then I've also got a USB-C plug because I bought a USB-C negotiation board. And what this thing does is when I plug in a proper USB-C power supply, hold on, I'm hiccuping. This is my body going, too much talking. When I plug in a USB-C cable, what this will do is this will negotiate for 15 volts. And so the 15 volts goes into all the rest of this stuff and it creates the plus minus, etc. And then I have current monitors on those voltages that are separate from the module testing board. This is just random old perforated prototyping board from eBay or Amazon or whatever else. And it just happens to be the right height that I can hold it into the modular synthesizer. This is a tester. I don't even think we're going to be using this today because I want to plug this thing in and measure the voltages. This doesn't measure voltage. This creates signals. This is the prototype for the module testing module. In its eventual form is going to be a lot of code and a lot of reference voltage devices inside of a muxable thing that can then test itself, get it tuned, measure inputs, perform outputs, all with a little screen that I can control it with. This is its like proto form. It's very first beta form. It's enough that I can tune stuff sometimes, but we still need to use the oscilloscope. Removing the requirements means more fiddling than running Linux to keep it working. Yeah, and I've been using KDE on the portable machine, and it turns out a lot of the stuff I do on a computer nowadays is just available online. Like, you know, Google Documents is what I use. And I know Google is super big evil, but and you know, de-Googling stuff would be nice, but still, if I want to put something in a spreadsheet, I can just open a Google Doc and do that. For now, at least until, I don't know, they do something else that's totally freaking stupid in order to make us sign up for more accounts and pay them little bits of money for $3.99. Somehow all these companies decided that $3.99 was the breaking point of most people's budgets. And so if you want slightly faster shipping, just pay $3.99. If you want to have fewer ads on your TV show, pay $3.99. I F5'd myself right into an ad. I've got the ad stuff turned down as far as I can do it. At a certain point, the execs want you guys to have eyeballs on stuff, and so I can't prevent ads in that sense. I miss the days when Twitch was supposed to be people funding their entertainment. You know, your subscriptions were supposed to be the incentive and where Twitch gets its money from. And then they decided, hey, this is cool, but what if we also did ads? And then we can put ads on streamers' streams who don't get subscriptions and we can still get money from them. Because we suck. All right, actually, I'm going to power this up for the first time, so I don't want it to be attached. I need a USB cable. Oh, there's one right here. That's right, I have that one floating around just in case. And this one goes back to the power supply. Yeah, okay. I bought a USB-C power supply with a bunch of sockets in it, so I'm in the modern era of USB, and I can power my projects properly. Ta-da! Okay, there we go. And then let's put the well, we'll see about putting the O-scope up in just a minute. Sadly, I'm too broke right now for subs. You don't got to worry about that. Don't worry about it at all. Yeah, I really miss the era where there were no ads on Twitch. That's how they do it. That's how they always do it. Everything. Cable did this too. They said, pay for cable and you don't have to watch ads. And they said, wait a minute. There's like a big chunk of money sitting over here. I hate that though. It's like, why do I love Twitch? It's because I can fund my own entertainment. But, oh well, that's where we are. So this thing plugs in, it'll get a little bit warm, it won't get hot. And then when I flip that switch over there, all the power supplies turn on and we get power into this thing. I can show you right now that the tester module has one of these bicolor, OLED screens. So I set it up to do cool stuff. And I could change the parameters of some of these with the buttons. This is using one of these minimalistic, whatever it is, screen libraries to draw circles around stuff. I love it. It's very nice. It's very fun to do. I used to pay for Tub Bro, but food and roof is more important than the budget. Oh yes, yes. I actually need to cancel my gym membership. I've been giving them free money for a while now. Jeez. All right, so I'll turn this back off. Bonk. And what I'm going to do is I'm going to plug in the MIDI CV module. When we plug it in, we do full send. I send all the voltage to this thing all at once. We will look at the current and we'll look at the thermal camera. You see, I do a full send because it's funny. And doing a full send when you're actually doing engineering, like if you're doing this in an office environment, it's much different. You start with a current limited power supply and you limit the current to very low. And then you put a low voltage into it to see if anything immediately shorts out. Then you go at a slightly higher current, or slightly higher voltage until you get to your operating voltage. And if nothing seems to be exploding, then you full send the amount of current that you figure this thing will draw. So you kind of figure it out. You say, okay, it shouldn't be more than an amp. An amp is pretty generous. And you send an amp of all your voltages over to this thing and you monitor that current display on one of these adjustable power supplies to see if anything goes awry. But because we like to be entertaining here, I'm just going to plug it in and turn it on. It's also hubris. I am being completely cocky about this. So, because my work is awesome and there's never any problems with it at all whatsoever. Oh, maybe I shouldn't press on that. Yeah, that's not a good. Okay. So stripe up top where it says red stripe so that our pluses and minuses are in the right spot. Now they designed this, when they designed this board, they actually did put diodes in place. We are missing coils. The coils are there to clean up the input power signal, and this should be a pretty clean, albeit a little bit solder burned, pretty clean input power signal because of the Pololu regulators are very nice. Where else were there coils? I think there were coils on, where were the coils in this thing? Need to figure out where those coils are. Because we just bypassed all the coils that we found. Freak out. Where are... Okay, so there's one here. That is on the DAC power. That should be pretty clean, to be honest. I don't think a coil would do... Well, you know, if we get weird stuff out of that, we'll look to that. We still have the capacitors on it too, so... But the coil is there in case of high frequency fluctuations in the power supply. If there's like a noise from something, it gets in there, the coil will help suppress it because a coil hates change. They resist change. When you try to up the amount of energy in a coil, it has to build a magnetic field, and so then that'll lag the increase in energy a little bit. And if you remove energy from the coil, it will lower the magnetic field and it'll convert back into electricity. And so in that sense, it takes a little bit for the coil to do stuff. And if you've got a super high frequency going in there, then it can suppress it. So that is the role of coils. And typically on these kinds of systems, you don't see them very often, and they probably put them in there maybe because they had some, I don't know, external ground loop stuff going on. But this one is between analog VCC and VCC, and that's just a reference voltage. So I'm trepidatious about having shorted out all of the coils, but especially these two here are completely unnecessary. Those are just the power supply coils in order to keep your power from having something weird going on it. And I'm confident enough in our power supplies that it's not going to actually have a component of that in there. And I've gone through so many different synthesizers that don't have this level of filtration coming in. The 47 UF is fine. That's there to make sure that everything is smooth as well. So a capacitor will charge up to a voltage, starve out the rest of the circuit until it charges up to its voltage, because it acts like a short, and then it charges up, and then it holds that power there, and if anything fluctuates downwards, it'll supply power to that circuit in order to keep it in the same spot. So both of these do their job in a slightly different way, but they supply energy back into the system or slow down energy going into the system in a way. This is more blocking and this is more slowing. But anyway, the diodes are here for protection. Those are a great addition to this thing. We have diodes in place. We have all of these components in place. The only thing we're missing is coils. I was just making sure that the coil wasn't involved in some kind of like an audio filtration thing. But I don't think it is. It's just there to stabilize everything. So we're going to full send and watch this Arduino microcontroller blow up. Or, well, microcontroller. I don't think it's Arduino, but yeah, here we go. 3, 2, 1. I'm going to look at the, hold on, look at the current. No 3, 2, 1s yet. Give me 1 sec. Slew that in the middle. Yeah, no blue smoke, no blue smoke. I would do a gamba, but I'm feeling confident in this, and I don't want to delay, and we don't have a ton of viewers right now. So 3, 2, 1, go. No movement. That's good. That's a good thing. No LEDs. That's a bad thing. Microcontroller's not getting hot. Oh. Uh-oh. The 7805 is getting hot. That's typical. That's a typical 7805 thing. Oh, that's good. Oh, that's bad. Is this thing out of its league because it's an old 7805? Or maybe it's in backwards? We got to check to see the voltage coming out of that to make sure that that's operating. Microcontroller appears to be operating though. Does that count as on? I think that's just being illuminated from, yeah, it's just being illuminated through the lighting. Yeah, nothing's doing on that. Of course, nothing will do on that because that's part of the analog circuit. Okay, so out with the multimeter now, or we could use the scope to test the voltages on this thing. The other thing we could probably do is get the MIDI keyboard over here and plug it in and see if it does anything. But first, I think we should check the voltages. This is your typical circuit troubleshooting. Test the voltages. When you install 7805 backwards, it becomes a 5807. A 5087 is a smoke generator, right? Okay, well, let's get the O-scope up on screen then. Let's see, that means I need to go to here. I haven't automated this yet. Whoa, what was that? That was a settings tab. Let's see, this would be framed overlays. Oh wait, no, I'm going in here. I don't need this. Part of the test is also plugging it in for an extended amount of time to see if anything blows up, although this is not the time for the extended test. The extended test is when you've generally got the whole thing working. Scope, boop, bonk. Okay, so there's the scope, and currently it's on its default. So let's bring it up so that we can see 5 volts on it. Don't go in the wrong direction. Okay, 6 volts at the top right there. Let me get the probe. With the probes, those are the special probes, and then I bought these BNC to headphone jacks. Those are great for modular stuff. Why did the congratulations music from Deltarune stuck in my head? Do we love rotary encoders? I have a variety of them. They're useful. I don't know. I got no complaints. Okay, let's plug in one probe and just see if what voltages we've got sitting around. You can't even buy a 7805 without an integrated heatsink now. These are notoriously low current, the ones that are in the TO92 package. You can't get a lot out of them. Oftentimes you don't need to, but we'll just check to see that we've got the right voltages sitting around here. So I need some kind of a ground. And I don't really have a ground lug on this setup, although I could maybe just get it from here. And then we can test. This is kind of remote because the loop then goes around the whole machine. There's our 5 volts. So the machine is getting 5 volts as prescribed. So by all means, it might work. And then over here, we should probably get plus or minus 12 volts on one of these. Actually, over here. Yeah, here, let's go up a little bit and just make sure that our 12 volts is getting to the TL074. Minus 12 volts. Looks pretty stable. Plus 12 volts, pretty stable. Second thing, turn it off and look to see the direction of all the ICs, because that's easy to get wrong. Like 100 milliamps, I think they consider on 300. We weren't even showing 10 milliamps going into this device, so. Okay, so let's look at the layout of this thing. Make sure that our ICs are facing the right direction. So the two, these three are facing up. These two are facing down. Facing up, facing up, facing up. Facing down, facing down. It doesn't have a notch, but it has a dot. So by all means, this thing should be working. I can check to see if every IC is getting the proper power. I didn't see any activity from the LEDs, which is odd to me. It might require some nuance. I would at least have had something blinking in order to give me an impression that something was outputting, which makes me think that something isn't connected properly. It's possible that maybe this was a bad idea and that those are actually, maybe that's preventing it from functioning. I thought maybe the clock pins would be, that actually might be the problem. Actually, that might be the problem. Let me fire up the soldering iron and get rid of this little bridge. How else can I cut that? I can put the knife down in there. I'm thinking about this now, like, wait a minute. If I had 2 clock pins and 2 capacitors, I'd probably move them in like this and put them directly to the crystal pot. Why did I think that those were the grounds? Dumb. You are isolated. Okay, so with that isolation, I think we can now get a clock signal into our microcontroller and maybe this thing will come to life. That sounds like exactly the thing. So that was a little spout of professional troubleshooting. That was something that I knew I would do something dumb, and it was bridging those 2 pins on the clock. So let's just see if I'm still jealous of the Rigel scope. I can't justify buying one. It was a couple $100, but it's like the star of the show sometimes. So I figured I had been using the 1054Z Rigel scope, which is great scope. You get a huge variance in frequencies, and Rigel does not care if you hack it, you can hack the scope very easily. Just look that up online. How do I hack Rigel scope? And you'll probably find the website with all the keys on it for all these different features and stuff. Because when a company buys this scope, like a Rigel scope, that sounds like a song. When a company buys one, they will pay for all the stuff, and that's fine. But when individuals are buying the scope, we just won't pay for those things. And so having the individuals able to access those features makes it so that you go to the company and you go, hey, why don't we have these features that I know how to use? It's very clever. I hope it works for them, their marketing scheme, because it's one of the few things that's kind of like nice for the little consumer like me. And so when it came time to shop for a new scope, because the old one was pissing me off, the 1054 doesn't really have, it has like a monitor output, but that's it. And so I didn't really want to dedicate a capture card to that scope. I was like, man, it actually doesn't have an HDMI output, unlike almost every other scope now. So when I went to shop for the new scope, I bought this and hooked it all up, and I said, wait a minute, there's an Ethernet port on this thing. And I discovered that you can actually just access on your intranet, you can access this screen and you can click on stuff. It's amazing. It's like perfectly integrated into the rest of the stream, and it's fast enough so that if we're troubleshooting stuff, you guys can see signals going on. There's something magical about that green CRT. I would like to go get that running with something that can display chat on it, because I think that would be very nice to have sort of over by the rack mount stuff. And then if I have to go poop like I did earlier, I can put chat up on screen and you guys get a kind of a cool little monitor display. It'll be a nice little like physical scene. Okay, anyway, power up, but this time with a working crystal. 3, 2, 1, go. Okay. Okay. 7805 is heating up. Push the button. Flip the mode. Still nothing. Nothing. Beep, 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 beep. Beep, beep, beep. Beep. I should at least see something coming out of that LED. Okay, so what's the problem next? We got to chase down our voltages. So the Atmega 328P, I do not have the pinout memorized. I don't have the pinout memorized on this thing, so we got to go to the schematic, and that'll tell me what pin power is coming on. What pin power. Pin 7 would be this. So pin 7, we will test. I need a better ground lug than this. Hold on. I wonder, is the standoff? No, the standoff shouldn't be responsible for mating the two boards together. That would be absurd. I wouldn't put it past them, but that would be absurd. 1, 2, 3, 4, 5, 6, 7. Oh, you guys can't see the scope right now. That is at 5 volts. Let's put that scope up. So you can see right there, it's at 5 volts. What could it be? That's at 5 volts. Let us check the... Well, most of what I'm concentrating on right now is just making sure that this microcontroller has all of the stuff that it needs in order to operate, because I figure there should be like... the LED should do something when I push the button, right? Is it like... No, that should be very clear. Are we outputting anything? Negative. I mean, we don't have an input right now. Maybe it doesn't do anything unless it's plugged into MIDI. What's up, Make Mistakes? How's it going? Got some of the old school names in here. We already checked this gets plus and minus 12. That's definitely, yes, still functioning there. Still functioning there. Check the clock signal. Maybe it's a little dicey. We got to zoom in to check it. Well, it doesn't look like a clock to me. Maybe this pin. Yeah, there's almost something there. Ah, it scared the crap out of me. What's your problem? Jeez. What are the crystal pins? Are pins 9 and 10, actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it's actually these two. It doesn't really look like a crystal to me. Do we break the crystal? Or is it going too slow? Doesn't appear to be going too slow. That's not really so much of a crystal. Yeah, those, maybe. Soldering should be okay over here. Oh, it's not. Okay, there's our problem. Crystal problems. All right, power down. Great, it's like the hardest place to solder, and that's where the problem is. Let me try to get things in position, and then I'll... Yeah, it's a tough spot indeed. All right, so let's try to get that soldered in. And I'm gonna put on a different tip on this thing. I guess this one should be okay. This is all part of the process of building something, is all the troubleshooting that you're gonna have to do. And bad solder joints are the things you're gonna be chasing down mostly. I figured if I didn't see anything on the LED and the microcontroller is getting proper power, it means something else is preventing it from doing its job. And so checking the crystal is just one thing among the things you should check. Whoa, why did that move so much? It's like it broke off. I wonder if it got damaged when it's connected to itself. Yeah, there's just a blob of solder sitting up in the atmosphere there. It needs to actually connect to... Let's put a little dollop of flux in there, and then I can get it to flow onto the wire. The wire... Oh, geez, I'm melting my probes. Damn it. The wire will often... this wire will often be a little bit oxidized just from my handling of it. And so it doesn't like to take to solder very, very easily. This is just one of those problems. I keep brushing the iron against my ground lug. I gotta move the ground. That's ugh. Okay. There's like a rubber coated thing from the scope, and it's enough that if I brush it with the iron, it'll start smelling like burning plastic. Okay, carefully now, because you can easily solder to the case of this crystal. So what I want to do is be careful not to touch that case with the iron. I don't want to put a little blob of solder on it. There we go. Oh, damn it. Okay, all right. I'm gonna put this in the vise so that I can play around with it. I need to get that wire to go out to that location and connect to the other side of my cap. Did you bodge surface mount caps into a home for some ceramic? Yeah, that's the entire... So I wanted to build this thing with parts that I have. So that's exactly what I did. I bodged surface mount onto through-hole locations, which worked out really well when they did the stand-up resistors, but works really poorly when they have these sort of laying down ones. And these are those high... low value ceramic caps that you put with a crystal. So they're kind of special. I don't know if I have a through-hole equivalent, although I could probably steal them from a device that has a crystal and use through holes, but I'm not. I don't like through hole. I'm okay struggling with this stuff in this particular example. Okay, let's see. How can I position myself so that I can actually manipulate this thing and not hit every button on the mouse by rearranging stuff on my desk? What in the fuck is going on? Oh, we need a new one. The end of it popped out. This is what happens when you hit these little ceramic elements with too much force. It'll pop off the connector to the element. And so they are disposable. You just go and get another one. So what was the value on this one? It was like 22.022 PF. 22 PF. Okay, so let's find another one. This is, again, my whole little bodge thing would be extremely well received by some kind of a tape that has copper on it that can deal with the heat. It'd be 0.022, so this kit doesn't have it. I'm not going to go through all. We have 2.2U. We're looking for PF, so it's going to be in this thing. Yeah, it is a dead ceramic capacitor. We'll hold vigil for it later. 22P. That's right. It was 20 or 25. That's off by 3. This one's off by 2. So I think I used 20. 20. Actually, this one's much larger than its predecessor. Wait a minute. Yeah, I did use 25. I don't have any 25s. Oh, you know what? No, I used it from the cap book, the capacitor book. That one has 22. Your 22 capacitors, surface mount. Everyone open up your book of capacitors to Psalm 22 microfarads. Picofarads, actually. I was just... So 7 puff, 18, 20, 22. These are the ones we used. 22 pico. Careful now. This thing is so big that I can't see what I'm doing over top of it. Okay, there's the new one. Put this back before I lose it. 22 is also often used on the operational amplifiers to filter out high frequencies. Basically what happens is at that higher frequency, it will allow, I guess, a feedback loop to cancel out any sort of ringing that you get at high frequencies. So what the role of a capacitor is in a inverting operational amplifier setup. So here's the new business. Here's the old business. Should probably prep for this. Of course, then the tweezers decide to become sticky. This is like, I don't know how to prevent this. This is the most annoying thing because flux gets on the tweezers and then they don't let go of stuff. What the heck? Leave it alone. The tweezers are not supposed to stick to stuff like this. Jeez. Obnoxious. So let's see. That lead is, yeah, that's pretty good because I can just squish it to get a little bit more length out of it. So yeah, let's get the capacitor over here, and then I click the mouse. And then I move my hand and I click the mouse, and then I move my hand again and my entire setup blows up. God. My temper is getting short today. Please let go. Please let go. God damn. You know, it's like the basic premise of me utilizing a pair of tweezers is that it can hold on to stuff, and when I open the tweezers up, it'll let go of stuff. And that wasn't doing the second part. I only have those 2 requirements. I can't see what I'm doing. Light closer from a higher angle. There we go. This is why you build the circuit board from smallest to largest thing, so that you're not in this situation where your massive shadow is getting in the path of you soldering something. I'm going to mute the mic and begin screaming. principles of tweezer operation. 1, pick thing up. 2, let thing go. No, it's not your... Did I do this, streamer? I'm so sorry. That's like when you yell around your dog and they think they're guilty of something. Okay. Now, I can unbend that a little bit and get it right up against, I think it is already right up against the component. Okay, right up against the component. This is just so that I can get the iron in there easily. Those are like $300. Those soldering iron tweezers, they're not that useful. Every single electronics shop that I've ever worked at, there's been a pair of those collecting dust in the corner that I should have stolen. I should have stolen it so I had a nice example of why you shouldn't buy it. They seem very tempting. They're $500. They don't really do anything. They just really use them. Just use this regular soldering iron. Or go borrow your buddy's soldering iron and do that thing they do at the Chinese restaurants where they make the auto chopstick thing with a rubber band. All right, so theoretically, that's now connected. We're not going to ohm it out. I'm just going to try it. I'm just going to try it, and we'll see if we get any activity from the LED. If anything's doing. As with everything, do not be too hasty. Make sure the stripe is here and the stripe gets plugged in correctly. So stripe down, plug that in. Now, cautiously power on your device. For the most part, the voltage stuff has been just fine with this thing. So power it on. Still nothing. Beep, 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 beep. You, show me. Okay, nothing doing there. Heat on the board, we're mostly just seeing it coming from the 7805. Let's check our crystals. Crystal pins. We shouldn't have damaged the crystal at all. That should be fine with what we've been doing. I need a good place to get ground from. I guess I'll just get ground from the other device. It's not a good way to do it though, because it's too winding of a path. And you could be like, oh no, there's noise all over this board when there's not. That does not look like it's connected. What about you? See, when I was probing it before, it would suddenly connect and then we get an actual like crystalline from this. Actually, that does look crystally, doesn't it? It was 9 and 10, right? So 1, 2, 3, 4, 5, 6, 7, 8, and then these are the crystal pins. Crystal, crystal. Looks a little sus. That doesn't really look like a 16 megahertz crystal. 16 bagigahertz. Gigawatts. Hoyt's donuts. I mean, that wire bent a lot when I really shouldn't wrench on that wire because I'm going to break another one of these. But it looks very much connected. And we still get kind of this rough crystal looking thing. What about like digital communication lines over here? This speaks to a non-functional microcontroller in that it's not trying to communicate with the CV outputs. And we're getting like similar looking noise on all the pins. Ugh. Ugh. So what's going on, bud? You wanna give me some 16 megahertz action here? So it looked like briefly when we were poking around at it that it was actually outputting a crystal when I connected it through the tip of this thing. And this should have decent ground over there, although it might be better for me to pick up ground elsewhere on this board. I don't know where I would do that, unless I just plug in another power plug and use whatever the ground that has. So it would be doing this, and then I'd be doing the one in the middle. Oh, wrong one. This one in the middle. That'll give me a slightly less circuitous ground. Still pretty circuitous. You know, they have probes that are basically like this little coil spring that you put onto the probe tip, and it's got a local ground that sticks down. The crystal cannot be put in backwards. It is an ambidextrous part. Usually it's literally just a piece of silicon. My mini tester didn't read it in one direction. Huh. Well, there's no directional markings on the crystal. Like this is what's not connecting. Does Erica Synth say anything about that? Hold on. Well, theirs is facing the direction mine is in with the text on that side, so so there you go. Yeah, crystals they're ambidextrous. They don't have a direction. You know, you can see that in the symbol too. There's no directionality in the symbol for it. So we're just dealing with this little circuit right here, and what we should be seeing is a clock signal, and we're just not. I don't think I blew up the microcontroller. I think it probably still functions just fine. Why would the kit require it? What do you mean? Look at the C. I think it's pretty hard to actually blow up a crystal. I don't think we blew it up by having it hooked up weird. The kit doesn't require... What? No, the crystals are not directional. They're not directional. You may hook one up to power and one up to ground, one pin to one pin, but silicon dioxide is a pretty rock. Oh, okay. That's 2 more oxides. Is there still connection here? No, I cut the 2 leads there, so those should be separate. I don't think I could have marred the traces, although using that knife it could hurt the traces, but it doesn't appear that it has. We just get this kind of buggy signal everywhere, and maybe the circuit's okay and something else is just messed up. I don't think we did anything that would have blown up the microcontroller. I don't really think that's the case. And we're getting a solid. What the hell was that? Oh, we're on, yeah, we're zoomed way in. I see. Okay. So those are the power input pins. Those are at 5 volts. But it does appear as though something is awry with our micro. Turn it off and turn it on again. Dude. So, okay, let me get an Arduino for an example here. Turn this off, and I'll get the Arduino, which is still an Atmega 328P. Where is that? Here it is. And it takes the USB plug that I don't have around here. That's 12 volts, so I'm not going to hook that up. I might as well. I'm going to get a USB B plug so we can hook it up and we can look at the crystal and you guys can see what it should look like. What it should look like. What if I could plug the microcontroller that's on this board into the Arduino and see what happens? USB cables are here. I have a bin full of cables. and a USB-B, which is not easy to come by. Here's one. Nope, that's not one. Thought it was. USB-B slaps. It's such a great connector because it's just 4 pins and it's this huge square thing. You can kick it with your foot and it'll still work. Actually, I put that to the test with this thing that I built for OctoJ, who's my moderator, who's since gotten a life and gotten married and all that stuff. Crazy. He's off on his own. But what I built for him was a little kick push-to-talk. And so you can buy on the Amazons, you can buy a full, like, I think it's aluminum enclosed. I don't know. I think it's just mild steel. But anyway, it's an enclosed foot pedal switch. And so we hooked that up with a Hall sensor and a little AT-Tiny 85 micro. And that basically acts like a joystick. And when he pushes the foot pedal, pushes the button. It's a very simple layout. It's something that most people could probably build. I have 50 Type B host cables in a box on the shelf behind me. Well, I wish I had a slightly longer one, but this will have to do. It's just something that came with some programmer. So I'm going to plug this in. I have no idea what was programmed on this Arduino previously, but what we're going to do is we're just going to look at that clock. We're going to see what signals we should be seeing on pins 9 and 10. So pins 9 and 10. So this is just an old school Arduino that I keep around for examples. We are not grounded on the Arduino, so I need to move my ground pin. So I have these little pins here, and I need to put that into a ground as reference. Now we are referencing ground, so the clock might look a little funny. Because the clock, I guess, is just doing weird clock stuff. Why is it going over to, oh, that's going to a different chip. This is using, oh, it's using a resonator. Huh. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. See? Clock signals. So, at least on one of them, it looks as though stuff's going on. And if I shift this downwards and zoom in, shift it, zoom it, move the trigger up to it, and then we zoom way in. Oops, sorry, wrong one. Oh. Zoom way in. We can see a 16 megahertz clock signal. That's what we should be looking at on this on the other board. And so I think this one's very wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9. So pin 9. Push comes to shove. Well, no, we can't do it with this. We'd have to hook it up to a prototype board, and I would have to hook up the Arduino to its like master programming pins, and we'd have to reflash the entire hex file onto it. That's not outside of the purview of the things we're capable of doing, but I don't think I fully blew up the microcontroller. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's test pin 9 again with this thing powered. Let me get my power pin again. My ground pin, rather. Get this out of the way. So we know what it should look like. And it should be on pin 9. So we can concentrate there and see if we can get some kind of a clock signal on pin 9. Power plug. Power plug. You know, the weird voices and the funny accents that I do to keep myself entertained while I'm doing this stuff. Okay, so pin 9, 2, 4, 6, 8, 9. Oh, this thing isn't powered on. Well, okay. And then powered on. Oh, that's a 60 hertz resonance. Yeah, it's going and it's trying to start oscillating, but it's not. So either my crystal is dead or there's some bad connection. So maybe I need to try to resolder this over here. For some reason, it's fizzling out. And I don't think the value of that particular capacitor being off by 2 or 3 picofarads. I don't think that's going to affect it like that. Could it be a dead crystal? Maybe it could be a dead crystal. The voices in your head they're actually there. They are merely a figment of your insanity. Okay, that looks like it's definitely maybe soldered. And the fact that it didn't move when I kind of pushed it with that should be good. This one doesn't really look soldered, although it's hard to tell. So maybe if I just get in here with a little bit of solder. Yeah, that's going to be the biggest problem is this method of putting surface mount onto through-hole pins where I have to add this little wire, is that the little wire connection can be sus. And that's why I really want something like Captain tape that has copper on it. True, it could be a dead at Mega. Did I kill it? I don't know. I don't know how long it's been sitting in a box waiting for somebody to purchase. Troubleshooting is one of the big parts of doing DIY kits, and it'll teach you quite a bit about how electronics go together. Okay, so try again. Stripe going down, make sure to get that right, because if you do it wrong, there are protections in place on this thing, but I've seen many a broken module in my day. So I just spend an extra half a second to make sure that my stuff's plugged in properly. Okay, power it back on. Look for any LEDs. Still nothing from the LED. We're zeroing in on either a dead crystal or a dead Arduino. Blep. Blep. That should be a nice clean waveform. Oh, so those are connected together. Why do you not function properly? All right, let's get the crystal out of there. Let's move out the crystal. That'll at least open up this area too, and maybe I can make sure that those are soldered properly. I think they are. I don't think there's any problem with that. These are actually connected, but we'll get the crystal out and we'll put a different 16 megahertz crystal in there. That's why you buy multiples of parts, although it could also be the Arduino being dead. So actually, let's lift out the Arduino and put it into the, let's lift out the Atmega 328P and put it into the Arduino and see if it does a proper clock signal. Hopefully none of the other stuff that's hooked up to the Arduino gets belligerent. At least the crystal's starting to ring, it's just not doing it right. Yeah, I don't know what the deal is with that. And I don't know if it's the microcontroller that's not doing it or if it's the capacitors that I've included. But they're off by a couple picofarads. It shouldn't be a big deal. So getting something out of this big of a socket, you kind of want to just barely move it in either direction and sort of get under and pry it up. There are tools that are specifically for doing this so that you don't mess up the pins. But if I just move it a little bit each time, using the tweezers as a fulcrum, ooh, that's in there pretty tight. I'm gonna just put a little tiny pry into it. And then once it unseats, you gotta be real careful because you'll wrench it in one direction suddenly and that can hurt it. You don't wanna bend those pins all willy-nilly. They gotta go from socket to socket. And now let me put a mark on this one just so we don't mix them up. I've got paint markers. M for MIDI, or E for Erica. No, wait, this isn't. Or W for Wadio. Wow. Okay, so now same deal with this one. Yeah, the EEPROMs with the windows, you need the tool to do. If you were going to do it quickly, you can see how long this takes me to do to get it out of the socket. Now with the Arduino Uno, no, you still need the programmer, you need the flasher in order to flash it. And you can get Arduino to flash a hex. You have to do you kind of have to like bend its arm backwards a little bit to get it to put a hex onto a thing without using the bootloader. So we have the capability. It's just a pain in the butt to learn how to do again. And I have to go into the back end of Arduino in order to sort of get to the AVR dude tools that it's based on. All right, so this one going in here, it's an Atmega 328 going into an Atmega 328 socket. So it should be okay, although its pins are probably positioned and configured a little bit differently, but it should be compatible enough that we could at least see a clock signal on the clock. Put this where I'm not going to run into it. Bring this over here. Put a ground pin in our ground. Get the cable that I put away that I shouldn't have. I didn't know we'd be going back to the Arduino. Plug that in. Plug this in. Well, that blunk. Okay, so it says it's on. Check the crystal pins. And we get a clean 16 megahertz. It's not me, it's you. That one is filthy nasty, but this one should be working. So let us go back to the circuit and work on it and fix it. Do I need to remove... I just... I went to grab the camera and I accidentally slapped it and it went like right in my face. Stupid. Yeah, the chip is capable of making a crystal waveform. So I don't know where we went wrong with our craftsmanship, but I'll replace the crystal and then we'll also check out those capacitors. Don't eat the camera. No guarantees. Maybe I'll put in the larger chip ones and we'll wipe the whole thing. We'll replace all of the elements in here. My crystal kit could also be kind of sus here because I bought an Amazon kit with crystals in it, and it's possible that some of them are not as good as they could be. Okay, well, let's investigate. Too many wires, too many cables, too many things in my way. Get the O-scope out of here. I guess I got to do that manually. So frameless scope, bonk, so we can actually see what I'm doing. And then the Arduino with the MIDI guy in it. We're gonna, well, we'll just put it aside right now. We'll get it in a minute. We will get it in a minute. This goes over here. Okay, so we got a little work area here. Where's my vise? Oh, there it is. And well, right now we want to remove the crystal. That's going to be kind of tough to do. Actually, I think the big wide soldering iron will get to both of those pins, but I'll add a bunch of solder to them first. Craftsmanship? How dare you? Oh, get rid of this thing. Dude, okay. Oh, look at that nasty ass flux. Gross. Okay, so this thing over here, oh, like wires, soldering iron, cables getting caught and everything. Okay. I thought this would be faster, but it's a good example of troubleshooting on these DIY kits. Now, if I'd bought a kit that had all the parts with it, and they were all the proper parts and everything, I could have gone nice and slow and made sure that everything was done correctly, and then my solder joints wouldn't have been an issue, but here we are. Here we are. We are faced with the consequences of my own actions. This is not really something that we can do one pin at a time. I kind of want to just heat them both up to temperature and then pull the crystal off all in one. And then we'll toss that in the trash. So I'm going to use a big wide tip for this. Yeah, XKCD, move the hyphen. Everybody knows it. Everybody knows it. Everybody does it. Okay. I need to grab the crystal with something. Probably not my hands because it's made out of metal, or it has a metal can around it, and that'll potentially burn me. So perhaps, well, maybe just forceps? I don't know how hard I should be pulling on this thing. Removing a crystal like this is weird. I haven't done it a whole lot. Yeah, I can put light pressure on it that way. Okay, light pressure from there. And then this, I can hit both of these pins at the same time, and it's twisting. Damn it! Would you just do your job? Okay. Grab it lightly. Heat both of these. Give them a minute to fully get to the other layer of the board. There we go. Crystal's out. The word's out on this crystal. One pin connects to the... No, both pins are isolated from the can. Yeah. Okay. All right, so now let's clean up the area. So desolder braid is probably going to be our friend. Damn it. Here. Instead of the solder sucker. Because these the pads for these things are tiny, teeny, tiny. I guess I'm going to keep the big iron for a minute. Just so we can clear this whole thing off. And I'll get the capacitors with the big iron too. Yeah, we'll do it from this side. Oh no, there's too much stuff in the way on this side. We'll go from the other side. I'm going to clean up the whole area, and we'll just redo the whole area. I don't really like the vacuum grabby pen. I mean, that is a good application for it, but I just don't... they don't give you enough feedback. They're great for dropping surface mount parts down, but... the forceps were perfectly fine for the task. This is not a great application of the giant iron tip, is it? Looks kind of damaged. Is that? No, that's solder in there. Okay. It came up very cleanly. I mean, that was like no effort. Actually, filling these from the other side would probably have been a good idea. Because then you get like the drip down effect. Damn it. Try again. Go to a clean section of this. Damn it. There you go. Okay, those are clean. Now we need to clean off the other side. And get the capacitors out of there without melting everything. And then I'm going to have to use ninja skills in order to resolder the two caps. I mean, I suppose I could do it from the other side. That might be advantageous because there's nothing in the way. I'll do it from this side just not to violate the normal expectations of society. We live in a... All right, that one goes into the sponge. Okay, no more. Let's hop to the other side of the board and see if we can't get the solder off from here. Same method. I'll just remove the solder for now, and we're just going to be putting solder back into it, but I just want to have a clean slate on these. The problem with the big iron is that I can't tell where it's touching the board. I can use a little corner there. The big iron brings with it all this heat and heat inertia, so that if something is particularly heat sinky that I'm soldering to, it'll just overwhelm everything before it's able to, before the trace is able to suck away all of my BTUs. Okay. I have a cap tester, but I don't think it's really going to test those very effectively. And it's not like these need to be laser precision caps. So putting in the 20 PFs should be just fine. 20 PFs are also a slightly larger cap, so I'll have a slightly easier time putting them into this system. What's 2 picofarad? If I really wanted to, I could put a 2 picofarad capacitor on top of these so that they are in parallel, and I end up with 22, but I don't think that's going to make much of a difference. All right, so we're flipping this thing around again. Oh, you know, I added solder to all those pins. Yeah, that's fine. We'll leave them the way they are. We don't have to remove the solder. That's silly. Now, how big are these? Are these big enough that they will span the through holes? Oh, they're very close. They're very close. I don't know if I can get surface tension to allow for that. And also, please let go. You can let go, tweezers. They're gone. You can't bring them back. I want to put them on this side. I don't want to put them underneath. I debated about that, but this is just more whatever. I've got room now that the crystal's not in there. I just have to manage my shadow. My echo, my shadow, and me. No heat from the iron. What's going on there? I'm going to be hitting up against the 7805 while I work. So I'm going to come in from a high angle. A guardian angle. Oh, what's going on here is that I think one of these is ground. Yeah, one of the pins on this, and I think it's the center one, is ground, and so ground is sucking away all of my BTUs from this iron, and so it's struggling a little. I'm trying to make a massive solder bridge so that I can get the gap without having to put a wire in there. He's wearing a wire. I kind of want to move that up a little bit. It needs to be, I want it to be right in the center there so it doesn't collide with the crystal thing. Better. All right, I'll load this up. This one should be more solderable. There. Yeah, that's pretty good. I'm happy with that. Do that on this one. I think I've done this before where you float the component in the middle, and if it's 1206, it can barely reach. Just like that. Perfect. Hey, this is a long forgotten method that I had. What is that emote? I can't see what that is. I'll look in a minute. Sure, it's not too offensive. Beauty, beauty. So there's our 20 PF caps. Now we know that they're making good connection. It's through a lot of solder, so you know it's not ideal, but I don't think it's going to affect it that much. Shouldn't affect my child. That doesn't look soldered very well. I don't think this affects anything, but I'm just gonna make sure that that's there. I think it's for an LED. Okay. This PCB is a kit. I find it rude that it won't work the first try. Yeah, what were they doing? You know, this isn't my fault. All my substitutions and stuff. I substituted eggs for milk. Your recipe was terrible. Where's the crystals? I know I just put them in here. Those are capacitors. I have a little kit full of crystals that we've been using. It's the newest kit that I have. It seems to have vanished. I'll find it. It's just right in this drawer. It's just covered by stuff. It fell to the side and I didn't see it. I gotta look down, so there might be some mic scratches. Looking deep into this bin of stuff for a crystal. A magical crystal made of silicon. And probably some other stuff. Where did it go? This stupid kit. All right, hold on. I know I just put it in here, so it's like definitely in the drawer, right? Right. Unless I put it just like by the wayside over there. I don't see it though. No, I don't think I'm that disorganized. I'm close, but I'm not that disorganized. I definitely put it either that or it's shoved over here in the wings. It's not over here. Nope. Okay, so I think it's in the drawer. There's just like a big pile of crap over here, and it's like, well, is the crystal over there? No, it's not. It's this whole divided organizer bin that's filled with little crystals, so. I have a lot of these little organizers, caps, more caps, trim pots, transistors, JSTs, random through-hole stuff, more caps, LEDs, trim pots, buttons, more caps, more JSTs, trim pots, more JSTs, JST PH, random audio related through-hole chips. Okay, maybe I didn't put the kit in here. It's still not showing up. Micro stepper motors. We got to do something cool with these. We haven't done anything cool with those. I am of a mind that the crystals are not in this drawer. Seeing as... And this isn't the... Okay, so there's still two more. Button sampler. More buttons. Shrink wrap. I'm also similarly organized in the abiotic factor. More buttons. So none of those are crystals. We can start to fit these back in. Oh, hey, computer power supply, right angle adapter. That might be useful in the computer build. I'm going to put this over with the other stuff over there. And maybe in the meantime, I will find the crystal bin that you guys stole from me. Maybe I'll just happen to come across it. You know, we won't point any fingers or anything. but, you know, if you guys stole it, and I'm not saying you did steal my crystals, the new kit of crystals that I have with all kinds of different values of crystals in it that you guys were kind of eyeballing, you know, maybe I just find it back on the desk when I get back. You do your thing. No judgment. I'm back. I caught you. Where else would I put it? Maybe it's over here. Did I put the kit over like on top of this thing? Yeah, I did. There it is. There it is. Just found it. It's right there. Okay. Well, let's work on this circuit now. Can you tell I like to just hop on Amazon and buy a kit of components, and then you have like a wide variety of stuff that you can use? All right, I'm gonna make a little bit of room down here for these kits to kind of sit on top of everything. Like derelict stuff sitting at the bottom of this bin. And then we'll start to pile up these guys in a disorganized fashion. Shrink wrap as a divider. I should kind of go through some of these JST connector ones and reduce them. Okay. That drawer has a lot of stuff in it. I yeeted it. I mean, bad crystal, bad solder connections, I don't know. Either way, we're solving both of those at the same time. The 1206 parts are luckily large enough that I can solder bridge to them. So we need a 16 megahertz. Luckily, we've got a couple in here. I don't know to what quality, but this says 16 on it. Put this back where these belong. On the other hand, I buy only a few things, but a lot of them. I have a bag of 10,000, or no, a bag of 1,000 microfarad ceramic caps. Well, 22 picofarad is not really something that I stock up on, although it is a useful value when you're dealing with this era of microcontroller, especially if you've got a lot of Arduino fires burning simultaneously. Is that going to contact? No, it's got a nice little separation there. And so we can just jump to the other end and solder these and clip them. And then when we put our Arduino back in, I keep calling it an Arduino. When we put our Atmega 328 back in, it should work. Oh, 1,001 microfarad. 1 UF. I mean, if they're 0.1, I would understand having 10,000 of them, but I mean, SpeedyCat does the same thing, and I don't really do that kind of hoarding of stuff, because you end up with boxes and boxes of things. Although I buy the kits because they make me a little bit more flexible in my repair abilities. When you run into something weird, you happen to have 5 of them. That's just how I like to kind of accumulate things, and that way you're not specialized. It's like I have 10,000 Arduino Pro Minis. Well, that's an obsolete microcontroller. Why are you getting so many of those? So that's how I operate. All right, just make sure there's plenty of heat going into that so that it solders nicely and gets all the way into the via and all that stuff. And then pull your dry sponge out with the soldering iron just to frustrate you. It's just specifically to get frustrated at. Cram that back in there. Okay. I like the 1 microfarad. I use them all the time for testing. And they're, well, yeah, you can get stuff on AliExpress. You can get 10,000 or something. From AliExpress, I wonder what the, excuse me, oh my God, what the variation in value is. Like how accurate they are. A lot of the time, it's just like something just needs to have a capacitor present. It doesn't need to be a particular value. you know, close enough. And I think that's what's going on with this. Hopefully. Hopefully we see clock-like signals coming out of this thing. Otherwise, we got to start blaming other stuff for not resonating properly. We could put the Arduino in here and see if it resonates now with the Arduino. And if it doesn't resonate, yeah, let's do that. Let's put this in, because the power pins are going to be the same. It's just there will be functionality tied to other parts of the board, but I don't think anything can really get damaged. It's just an op amp and whatever it is, data acquisition, digital to analog converter setup. So we'll just see. Let's see if the Arduino resonates in this thing. And I should probably plug in the rest of the electronics because that's where the power's coming from. Make sure my standoff is aligned. Yes, okay. Trading places. Okay, and then we need a ground, and I guess the best we're going to get is from power cable. Be nice if there was just like one socket on this thing where I could plug ground into. That depends on how much troubleshooting we're really going to be doing on this thing. Hopefully, we just solved all the problems. Bring the scope back. And focus your damn video equipment. I thought that's all you do here is video. All you need is just a pretty looking picture. Can't even manage that. Old crystal, you go over there with all the trash. Scope hat. Definitely, definitely just stick around the scope, please. Don't get lost. Usually I have them in a drawer. I like to drawer things. 16 megahertz, 20 picofarads. Little bit weird on the soldering, but at least we know they're connected. And pins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 2 crystal pins. 3, 2, 1, action. Ooh, still looking rough. Still looking rough on both of them. Why? What else could be? There's nothing else connected. Unless it's just the weird ground that's not giving us the proper display. Hans Rosenberg, decoupling issue with the caps. I retested the DIY kit, working in both. Bad solder job on my part. Oh, yeah, that's what it always is, right? It's always one of those. Whoa. Whoa, whoa, whoa. I mean, 20 picofarad versus 22 picofarad. I should be seeing a clock in here. What in the F is going on with this? Won't see anything there. Is it just that it's going through too much stuff? Let's find a more local ground. More local ground. Let me see. What are ground on this thing? Hold on. Get over to, well, actually, the other side of the capacitor should be a ground. So if I'm on one of these pins, no, maybe that's ground. Oh, there it is. Okay, so this is in line with what we saw. It might have just been that my ground was not nearby. Let's put the MIDI thing back in. What class are the capacitors? No idea. Capacitance versus inductance within the range of caps he used. Reduced the noise greatly. I see, I see. Well, okay, so the ground that I was using is is associated like down there. So it's actually going through a huge loop. So when I localized the ground, I actually got a resonance, a 16 kilohertz resonance or megahertz, whatever. having the capacitor values be off by 2 picofarad is not that big of a deal in the grand scheme. Yeah, I don't have one of those tools anymore, the ones with the 2 hooks on each side so that you can evenly back something out of headers. So I just got to be real cautious with the way that I move. And I am putting pressure on this part right here, the little DAC. One's a 1-channel DAC, the other's a 2-channel DAC, because this thing can output 3 signals. There you go. All right, you go back in the Arduino, and then you come back over here and go into the MIDI thing. Go in your home. You can also insert the tweezers and flip them from side to side to start this thing moving out of the socket. So it goes in like this, and then I twist one way, and then I twist the other, and I just back it out a little bit on each side each time. Just little by little. Little by little, and I want to go side by side, and then the whole thing comes out as one, and you haven't bent any of the pins. So Arduino goes back in, lives for another day to fight whatever fight we're going to put it in next. All right, that goes back on the shelf. This comes over here, pin 1 to pin 1. Pin 1's all the way over here. Big chip goes back into big chip home. Make sure all of my pins are in all of the sockets, and then give it a little push on each side, and we are seated again and ready to go. Even the strictest data sheets for a crystal in that range call for 18 to 22. Okay, so we're in that range, so this should be fine. I mean, we saw our 16 megahertz signal too, so now we're going to double check to see that it's there. It may have been there the whole time, and we didn't need to do any of this. I may just have hooked up wrong. That's usually the case, right? And it's something else that's broken, or maybe the LEDs don't light up. So power you on. I'm just wondering why there's no activity from the LED when I hit the mode button. And let's check the crystal. Make sure that we get a wobbling crystal over here. If I compare the to ground. Let me find like a ground pin. Hold on. Ground. 8. Well, that's right by where the crystals are. Funny how that works. 1, 2, 3, 5, 6, 7, 8. Ground. 9 crystal. 10 crystal. We're powered on, right? Yeah. Power's on. Pin 8 is our ground. Hello? 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. A little bit of sloppiness, but I think that's to be expected. And then this one's blah. Yeah, but here it's ringing nicely. We've got a nice 16 kilohertz crystal doing its thing. Okay, what are next? Well, maybe hook up MIDI and see if it does anything, because it's just a little strange that, oh, is that, it's like wrenched to the side. I must have done that with a vise. Huh. This looks weird. Okay, yeah. Oh, there's an LED. Yeah. Wait, so what? Was it not like pushed in properly, or now it suddenly works? Blink, 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 blink. Okay, so some evidence of activity. I guess now we can plug MIDI into it. What else is getting hot here? You can see this getting a little warm. I don't know, maybe just pushing down on it and seating it a little bit more, or hitting it with current suddenly made it work. I don't know. Strange, isn't it? Okay, so power it down and then get this out of the way and we can set up to actually start messing with this thing and seeing what it does and how it works. I told you guys, you didn't believe me. I told you. You never believe Bother. You never believe Bother. You say, Bother, you're just a big bumbling buffoon because you're a guy on the internet. You're some big jokey guy on the internet and you don't know what you're talking about. You don't know that it's going to take 5 hours to troubleshoot this stupid circuit that you built. We're not even done yet. We're just getting into it. I have to make sure that all my voltages coming out are proper and look right and all that stuff. But it took us this long to get the thing to just start even flashing an LED. And going to the instructions is probably going to be the good call here. I don't know how, I'm kind of cursing myself by attaching this thing at this juncture. You know, why do these modules cost $300 to $500? Well, you can see time is money. Time is money. But this is good for us. It's you know, this is why our coat is shiny. We get a little bit of experience troubleshooting, albeit frustrating. Okay, putting tools where tools belong so that I can find them later, because they will inevitably be needed. Hopefully we don't have to do soldering, but there's probably a couple more solder joints on there that are sus. I'm going to get, what am I going to get? Well, I'm going to stand up for just a second so that my blood clots can all filter out. And then I don't think we need anything else. Oh yeah, I'm going to get the MIDI keyboard, duh. It is a MIDI device. I need a MIDI keyboard. So I got this thing. Do I have a power cable for it? What power does it take in? 12 volt DC into this thing. It is a big chunky piece of plastic and it's kind of a little bit annoying how big this keyboard is. I would like to get a more slick one, but this is just what I've got. I've been learning quite a bit from this troubleshooting escapade, so thank you for that. The fact of the matter is that I was not testing that ground very locally, and so all of our theories about the crystal could have been wrong. The crystal might have been working this entire time, and I just didn't see the LED doing anything. I don't know. We poked it just right, maybe unseating and reseating the microcontroller. Got a couple more of the pins connected or something, but yeah, the one you got is, oh, the price new for this thing is $170. I'm talking about other modules too. I'm just referring to, in general, modular synthesizer modules and their excessive pricing. AC adapter, 15 volts, 3 amps. Nope, that's not the right one. That's not, nope, that's not the right one. That's not the right one. We need 12 volts and very little current because it is a digital device. Comp Renew, wall-mounted AC adapter. 12 volts, 2 amps. I think this is the right one. And then I need the MIDI cable, which is... where did the MIDI cable go? I only have one. I used to have a lot of MIDI cables. There it is. It's a little long. It's a little long, but that'll be okay. Okay. The whole kit and caboodle. I'm going to move the stool over here to put the keyboard on. Yeah. So this thing's kind of out of the way. I love how they sent me a Comp Renew AC adapter. Probably not what M Audio shipped. No idea if it'll blow up. I've used this particular kind of M Audio MIDI output thing before. We use this type of thing on the what do you call it? On the Fire Cannon controller, because the Fire Cannon controller it had 10 cannons, and we just set it up to be 10 of the ivories, and so each one of them had an attack on it, and if it was above 0, it would open the solenoid and fire a huge plume of fire into the air. So you could play the fire cannons like it was a piano. And then we would use the piano roll in order to animate the stuff. I forget how to change the channels and stuff on this thing, though. I'm a little fuzzy in the usage of this thing, because this is in like 2010, 2011 that we did this, and I always remember that everybody would call me over because your system is broken. And I'm like, bitch, it's just not on channel 0. The price of my Akai controller is $170. If you don't plug it into a PC, it goes into MIDI to CV mode. That's neat. It already has CV on it. That's like that. Yeah, but I'm not in a position to spend $170. I just got this thing off of eBay. I love my MPC. I've been looking for that song. There was a song about this guy, how much he loved his MPC, the drum machine, and or the whatever it is, the drum thingy-majig. And I can't find it anymore. It was in, I think, one of those mixes, those Space Cowboy mixes that I love using for stream, I think is where I heard it. I don't remember, but it was the song about this guy, how much he loves the feel of it and everything. He was like making love to his MPC. I can't find it again. What happened with the other device? What other device? The Fire Cannon controller got sold to some kids that didn't know how to use it, and they blew it up. And so they came to me and they said, I tried to put 12 volts on these pins, and they were pointing to the programming header that's on the top of the Arduino Nano. The very much not 12 volt compatible pins. They blew up their micro, and I didn't have a code repository at that time, so the code was gone. And so I had to reprogram it from scratch. Luckily, I kind of remembered what I did, and I got it all working again and gave it back to them. And since then, who knows? These kids that bought the thing are some of the most disorganized people that I've ever seen in my entire life. So I don't know what happened to it, but I think tech support on a 15-year-old project has ended. I think if they ever want me to fix it again, they need to come with a big check. The manual for the keyboard? No, oh, you have it. That's what it, okay, thank you. In case I need to change MIDI channel, yeah. I think this works off of channel 0, which is octave 0 rather, which is I think where it's set right now. Who knows? I mean, the previous owner of this keyboard was from eBay, so who knows? But I'm trying to unfurl my test cables. 1 sec here. This is a bad situation. What the? Give me this. Yeah. And we'll have to look up the documentation on Erica to see if there's other tuning things that I need to be doing, because slew is not just, this is basically a potentiometer that's in the path of the amplifier chips. So it's like a real manual way to change the voltage output. I don't want to rely on it for tuning. I want it to be in tune to begin with. It probably means I should have used 1%. That looks like it's an input. I don't know. Let's just check channels 1 and 2, and then we'll make the scope. I'll put the scope up on screen. And let's get rid of our offset, and let's bump this baby up to, well, it'll be 8 volts from the top to the bottom, and that's your typical CV output, or 1 volt per note output. I think CVs go to 5, but they all have to be compatible with plus minus 10 volts. But now let's turn this thing on, and we'll just check our scope. Oh, channel 2 needs to come on. Channel 2, and then get that up to 8 volts peak to peak. And then, what do I need to do? We'll check a signal. That's a particular voltage. That should be a waveform, but I think this thing is a little less reliable. Oh no, that's a time scale issue. Yeah. Because we were looking at a 16 megahertz clock. This is way lower frequency. There it is. Whoa. Oh, the thing went crazy. There you go. Okay, that one's good. Hopefully means this one's good. Yep, cool. All right, so hit buttons. Ooh, hey, blinking lights. When I press the MIDI button, I get the blinking lights. Yes. Ha 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 ha. Okay, let me get some cables here. Let's just see if these are inputs. I think they probably are. Yes, good. All right, a couple cables over here. Might be mic noise. Sorry. What are you ideating over? Okay, so if those are inputs, then maybe I can instead go there and then bring like this signal. This is the pulse and the other one's a triangle. So the pulse into here. That's not doing it. Nope. About clock out. I think this one, does this not have a clock? I think there's a tap clock on that. I'm not sure. Turn. Knob is slew. That's just going to change the yeah, turning the knob's not going to do anything right now. Unless I go into one of the CV outputs, the gate maybe, and just I got to make sure I'm on the right channel. Those are the different modes and also the keys that I'm hitting. So, all right, hold on. You guys don't got to tell me anything about my own setup. So I'm over here hitting buttons. All right, so we need to go to the right channel. And we need to learn what the ins and outs are on this thing. So let's see here. Keep in mind there's also a delay, so making comments on stuff that's happening immediately doesn't really work. It's all jumper. Yeah, we got that. You can achieve extremely accurate VCO tracking. Therefore, some calibration is required. You will need a VCO with a good 1 volt per octave tracking, MIDI keyboard, and a chromatic tuner. Bong. Connect the MIDI keyboard to the module. Set voice switch to 1 voice mode. We were in 2 voice mode. 1 voice mode. Still not seeing any output, but we need to set the keyboard up properly. So we need C5. Hold on. Connect CV1 output to a calibrated 1 volt per octave. I have a calibrated 1 volt per octave on the tester that we can use. Disconnect MIDI CV module from the PSU, then push and hold program button and connect the module to the PSU board. We need to make sure that we're hitting the right notes though. Place C3 on the keyboard and tune. Okay, so let's check the keyboard settings. We have the manual already selected by a viewer. The M Audio Oxygen series. Surely this will never become obsolete. Oh my God, this is very annoying. Let's see. I don't like this reader. A Pentium 3? Oh no. Seven functions. Okay, we're not going to use too much stuff on this. Octave plus minus and transpose. How do I set you to be? Yeah. Global channel. Global channel function changes the MIDI channel assigned by the keyboard to your Oxygen controller. Transmit anything. Press the advanced function, press global channel. Why am I going into advanced function? I should be in regular functions. Keyboard to edit mode and the keys. I think I'm in the right thing. I just want to make sure that I'm in a place where I can output to this thing and see the control voltages come out. And it's possible that something is still broken on this thing that we don't know about. So, because currently I hit keys and nothing happens. So where is C4? Let's see, data 1, data 2, data 3. Those are other things, but C4 should be somewhere around here, and I'm not seeing any output from the CVs and gates. I mean, we are seeing stuff go in, but... Oh, I guess program only works if you hold it down when you power up. I see. Clock out, no, that doesn't matter. This thing. So, I mean, we're currently dead. And I just need to make sure that I'm on the right. See, that's octave 1, octave 0. And then, let's see, channel. That's program. Keep an octave 0. Pitch bend. Okay, let's see. So advance channel global program preset 1. So the global is, I think, okay. Yeah, global 0. We're going to stay on program 1. So I think it's the module. I think it's what we're dealing with. I thought I said deleted. I deleted your sarcasm. Nah, that's fun. Look at the little light blink. that's all I got. That's all I got, chat. Is blinking. The light's blinking. Isn't that cute? So for my setup originally, when I was building something that would work with Star Citizen and have like all kinds of buttons that I could assign, I actually bought a little MIDI pad, and so it had a bunch of these big rubbly pads that you could punch, and they would be different like shit functions, like lights and stuff. That was neat. I used a free keyboard thing. It was like Python-based keyboard programming program. It was before I knew a lot of programming. Nowadays, I could probably throw everything onto a Teensy and make that work just fine. Okay, so I remember the Oxygen V2 was kind of annoying. It feels like a plastic toy, which is fine when all you need is something that produces any MIDI at all. So having these keys be the way they are is just, it's enough for me for now, because I'm doing silly modular synthesizer stuff. But right now it's in one channel mode. We're not getting anything out of what I've plugged in. Which begs the question, are the DACs working? We've clearly got signal going into microcontroller, and let's just double check. This is all still part of troubleshooting. I wanted this thing to work, damn it. When engaging the global channel function. Wait, what do we do? Press the advance plus press the global channel key. Oh, wait a sec, hold on. We've got to, let me just make sure that I'm on the right global channel. So advanced, but then which one's global channel? Oh, globchan. It's labeled globchan. Isn't that some kind of a, okay, anyway. Advanced, globchan, channel 1. I think we need to be at channel 0. Oh, it only has channel 1. There, channel 0. How do I select? Enter the MIDI channel number on the keyboard. Press the enter key. There's an enter key? mem dump, MIDI out, velocity curve. Oh, those are the numbers. Enter. Oh, there we go. Why does it say 23 though? Well, no activity from MIDI coming out of that. Channel assign. The channel assign function assigns a channel to an individual MIDI controller. Press the advance button and then channel assign key. I don't think I need to do channel assign. Oh, I see. There's a control channel and then just a channel assign. Channel 0. That's fine. Enter. Okay, I'm starting to learn how to use this keyboard. There's all these like alt functions that are written above these things. So 0, 1, 2. As I'm doing this, of course, I'm also outputting MIDI to this thing, and the LED is blinking. And what we want to do is we want to check to see on the schematic where that LED is connected, because that will tell us whether or not our microcontroller is functioning. So I'm going to look for the LED that's coming out of MIDI. And so the MIDI plug is over here. We've got VD2 over here. This is a 1N4148 diode. So this whole system is working right now, and the opto isolator is working, and it goes to MIDI RX. MIDI RX is up here with the micro. MIDI RX, UART, voice, UART, prog button, MIDI LED. Where the hell's MIDI RX coming from? Well, whatever. We can assume that it goes into the microcontroller. But MIDI LED is its own little thing, which I'm not finding anywhere else on the screen. Where's like this lone LED? Yeah, CVs and mods out, clock out, gate out. Those got the gate and the gate 1 and 2 output have their own LED. Oh, there it is. No, wait, that's not it. Where is it? There's probably just like a singular LED just floating out here somewhere. There's no second page on the schematic, so. Well, it doesn't matter. Either way it's labeled on this thing. We know it's there, and we know it's being powered by the microcontroller, which means that the microcontroller, middle of page on the right. Middle. Middle. The mouse is right over it and I didn't see. Yeah. Doesn't matter. It doesn't matter. I don't need to see it. Process of elimination. There's another MIDI LED going into the front panel. And there's the MIDI LED right here. So this is in reference to the two panels. So this is coming directly to the microcontroller through a 1 kilo ohm resistor. So, but that was all the way on the right side of the screen. Anyway, that's this right here. We didn't need to really see that. We sort of know that if there's a signal flag that says MIDI LED and it's coming out of the microcontroller, that we can be rest assured that the LED is being directly controlled by the microcontroller, which means it's not flashing because there's any data on the MIDI line automatically. It's flashing because the microcontroller is functioning. Let's move on. I don't care. You don't need to tell me about this. It's beyond, this is not the point. The point is, I press blink and light button, and we get blink and light because the microcontroller is doing its job. That means the microcontroller functions. Bada bing. So the question is, am I not seeing any outputs because there's bad solder joints on the board? Yeah, probably. Or am I not seeing anything because of the motor in? I don't think that's the case. So something else isn't right with the construction of the kit. So let's make sure that we're in the right like channel and stuff. What do we have? We don't need this. So connect the MIDI keyboard to the module. Set the voice switch to 1 voice mode. Okay, so let's do 1 voice mode. Channel assign. Mute advanced controls. Channel select, program, bank LED, bank MSB, data 1. I don't know if I have voice control. What is the, oh, Jesus Christ. This is a very annoying program to use on Archive. Control select button allows to set a MIDI controller parameter for editing. Use the control select function to select a MIDI controller before assigning a MIDI CC number to that controller. What does that even mean? That's not what we're looking for. Data 3 functions located within key bed. Function of data 3 depends on the MIDI CC that is currently assigned. That's not what we're looking for. There may be a mode on this which only does one note at a time, but I'm not sure. So this would be the M Audio Oxygen. I can't, this is not turning into a scrolling thing. Oh, I see, because I can grab the page and move it. Velocity curve, drawbar mode, polarity of the faders, device ID. I hate it when they do this with PDF viewers. I can highlight text, I can click and drag, or I can click to change the page. The problem is all of those rely on one mouse button landing in exactly the right way for it to happen. And so when you're clicking through madly because you've got 49 people watching you, you can tend to do something that it's not supposed to, like turn the page, or click and drag, or highlight text. That's blah, blah, blah. Don't tell me how to do stuff. Leave me alone. What is this? Buttons and pedal. Programming options. Yeah, I don't think we want all that. Let's search in the PDF. That would be this one here, and voice. One result. The original GM MIDI specification allowed for only 128 voices, numbered from 0 to 127. It's possible to access a different voice by selecting, oh, geez, I don't need to do that. Programming a button to increment, decrement a MIDI CC value, no. Ooh, this is very complicated, isn't it? M Audio Oxygen. One voice mode. Oxygen Pro. That's not what I'm looking for. Look at the weird plastic stupid one. What series is this? M Audio Oxygen 8, I think. Archive details, blah, blah, blah. Where's the, okay. We're on page 1. Wait, what? No, we're not. Oh, results, right. This is which keyboard? I mean, it's literally sitting here. It says Oxygen 8 V2. Okay, just verify. Oxygen 8 V2. $7.45. Store hauls, thrift store hauls. Oh, it looks about as bad as mine. Hold on, let's wait for Reddit to try to dox my email. One sec. Can I play Bossa Nova? Probably. Let's see. Hydrogen peroxide. Congrats. What is it? Acetone for the keys. Would you use for synth software? Nope, none of that's useful. 2 modes, preset and DAW mode. When DAW mode, all the controls in now. Digital audio workstation mode. That's interesting. You know, you can, yeah, hook it up to like FL Studio or whatever. Ha 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 ha. I don't know. You know, the onset of modular synthesizers probably means that more of these programs have more of these devices have in them programs that allow you to only have, you know, one voice come out of the thing, but I don't think we have access to that sort of a setting. Wasn't the one voice is the switcher? This is 1 and 2 voice mode. Yes, this is 2 voices, this is 1 voice. But this thing will output up to 128 voices at once. So if I hit all these keys, it will hit all these keys. How does this thing decide? I don't know. It's all in the MIDI messaging. So in this case, we want this in 1 voice mode. So what happens when I hit 2 keys at once? Because it'll get 2 MIDI messages for the pressing down of these keys, and it won't have the one that lifts. So maybe it'll only play the first one that it sees. I don't know. But that's not such a big deal right now because we just don't have anything outputting from the system. So we need to look in other places for what's going on. I wanted to make sure that I was outputting the right types of MIDI messages that this thing would respond to, so that we can confirm that it is something else that's the problem, that it's the hardware that's the problem and not the channel that I have this eBay bought M-Audio thingy-majig on. So that's why we're kind of like looking in a couple different places at once. Now it's time to use the module for your modular masterpieces. Now, go! I'm holding a gun to you. Well, okay, so channel 0, C4, or C whatever should be just fine, right? Which is, I think, the octave 0, right? If I go up an octave to like 4, I don't think that's going to suddenly output anything. No. See, there's just nothing coming out of it. And we're on global channel 0. Bank 0. You can go bank negative. You can go back channels. But we're on 0, so we should be seeing something happen with this. You can see there's a message when I push the key down and one when I lift the key. Down, up, down. You guys can't see that. It's flashing too quickly. You also have to aggressively enjoy. It says now it's time to use. It doesn't say enjoy. So I don't know if I have 1 voice on this thing. That's program change. Program 1, I can look at advanced, and I can look at the global channel. Well, it says channel 1, so we set it to 0 and hit enter. So now we're on channel 0, global channel 0, still no activity. So I can check the control assignment. That doesn't matter. Channel assignment, channel 0, global channel, that should be 0, 0, enter. Check it. Okay, global channel is forcing me to channel 1. Maybe that's because I have the channel assignment selected. Okay. Control select, program, bank, LSB and MSB, memory dump. No, we don't need to worry about any of that stuff. Okay, so let's take it off of the rack and let's check the data lines going to the audio conversion things, the digital to analog converter. The keyboard just does not have a monophonic mode in MIDI. It's that old. Funny that it wouldn't have that. That's such a common thing now. But I guess modular synthesizers back in 2010, they were still popular. You have to push 0 twice. Maybe it needs 2 digits. Let's check. So advanced. Channel, nope, global channel assign. Oh, now it's at channel 0. That's channel assign. If I go to global channel, oh, it says 1. So let's double 0 and hit enter and check. Global channel, still on channel 1. 0, 0, 0. Enter. Global channel still 1. That's just not letting me go to channel 0 on the global channel. And still not outputting anything from the device. Now, the device is not infallible. I built this thing, so there's obviously going to be errors in it. And if this thing is outputting on the global channel, I think, yeah. Oh, there's a power button on it. I didn't know that. That's for the sustain pedal. Hold on, let's look at the MIDI out. Ah, wait a minute. No, it's still, wait a minute. Store? There's a store for this thing? It's the first app store. No, it is outputting MIDI because we can see the LED blinking over here. It would be funny if we hook this up and we get like actual chords coming out of this thing. Global channel, global channel, global channel, global channel, global channel. I don't think hitting it multiple times is doing anything. What does PO8 stand for? Channel 1, global channel 0. If I go here and hit buttons, still no voltages coming out. Yeah, I think it's something in our system. I think it's something that we're doing. Power that down. Get her out of there. Sometimes you got to do percussive maintenance, right? Sometimes it's the number of curses that you utter that activates the thing finally. With many digital systems, that is the case. Well, our VREG is not the hottest thing ever at this juncture. And we know the opto isolator is working. This is working. TLO74, it's getting as many volts as it wants, but I don't think... Okay, which ones of these pins is ground? I would like to stick my ground in there. Let's see, back to the schematic, which is the most amount. We don't need the bill of materials anymore. The schematic is going to tell us which pin on that header. So pin 1, the square pin, is going to be my local ground. So what I'll do is I will get the scope probe and plug it into channel 1, because we're dealing with modular synthesizer voltages now. So we can keep the scope trained where it is and able to look at audio speed waveforms. And I'm going to get channel 1. This is the last stream with this that I will do with you guys. Any other further troubleshooting, which is probably going to be a major pain in my ass, will be done privately. I'll do it on my own and get it working just so that we can move on. Because with the modular synthesizer stuff, this is the tip of the iceberg. This is like the first in a string of finalizing many different modules that we're going to do. So now we look at the data line, the SPI data line that's coming out of the microcontroller and fueling our audio DACs. So these are the two things that we didn't see anything happening on, this MCP 4822 and MCP 4821. I feel like with all of these modular synthesizer projects, everybody is using a different DAC, and it gets very frustrating. Now I have like 17 different audio devices that I can throw at a microcontroller and create output voltages. These are through-hole, and they were hard to find. I mean, DigiKey had them for a couple bucks, and they were still in stock. So I lucked out there. Actually, was it DigiKey, or did I have to go to... I did all of these with DigiKey. Yeah, I was able to find them with DigiKey, and they had a few hundred in stock. So I guess they're not all that rare. They may be used quite a bit in some different kits and stuff like that. A lot of these like modules, if you're buying and building your own, they will use all kinds of different audio DACs. And then they'll use DACs that cost like $15, either because they're obsolete or because they are a bunch of, trying to think of an insult. They're just a little prissy. Chip select, serial clock, SDI, and LDAC are the pins that we're looking for. So 2, 3, 4, and 5 we're going to look for activity on. And let's see if we can get in here. I'm holding this to the side so that it puts a little pressure on the pin that I've put through the ground. And then I just go and I probe without getting in the way of the camera. Okay, all right. You don't, everything's like all twisty. Pin 2, pin 3, pin 4, pin 5. Okay. So if I hit a button on the keyboard, oh boy, I'm running out of hands. Can one of y'all hit the button on the keyboard so we get a MIDI message in here? Pin 2 is chip select. Aha! So there's a little bit of activity from pin 2. Pin 3 should be data. Wait, why is there a constant? One of these channels, this should be channel 1. And so that was just noise, I guess. Pin 3, MIDI message. We're not responding. Okay, so that tells me a little bit more. That tells me we might not be on the right channel. Oh, it's 2, 3, 4, and 5 of this thing. Oh, sorry, wait a minute. Pin 2. Well, let's chip select. Let's go to pin 3. And I hit buttons and nothing happens. So it is possible. Oh, we're not powered up. There we go. That's more like it. Okay. Well, wait a minute. That one is the one that's plugged into the... Channel 2 is at 2 volts, but... Does it change when I hit different keys? No. Why is it at 2 volts? It's on like a C note. Why would you do this? This channel 1 is where we should be seeing... Aha! Yeah, that's up at 5 volts. So let's pull a trigger up a little bit so we get some nice clean signals. Yeah, I know I can make MIDI. I also have a plug that I can put into a perforated prototyping board where I could make MIDI as well and control it a little better. Listen, I'm not... I have lots of experience doing MIDI stuff. What channel are we triggered on? I think we're on channel 1. 1, 2, 3. Pin 3 is serial clock. We should be seeing more from pin 3. Oops. Whoa. Don't want to short stuff out. Pin 4. 4 is SDI, so serial data. So if we are on the SDI pin and I hit a button, we should be seeing a signal in here, unless it's flying by so fast that we didn't see it. Why is there an Elgato, Marketplace Elgato? Huh. Yeah, there's lots of MIDI libraries for the Arduino. So I could potentially make a little thingy-majig. I don't know if we are outputting to the DAC. I think that's the problem here. So the microcontroller is getting a MIDI signal in, but it doesn't see any need to assert data on the data line, which tells me that we may be on the wrong thing. That's one of the best Stream Deck. Wait a minute, what? You have a keyboard Stream Deck. What the? I know Vinesauce Yol uses like an on-screen keyboard, to do silly bits with music. Oh my God, imagine having 3 Steam Deck XLs sitting on your desk. That's like $600, $700 worth of Stream Decks. Eesh. So this is MIDI output from your computer. I don't have the plug. I don't have a MIDI USB to MIDI thing. I couldn't use this. We need to get it right with the M Audio. I want confirmation of the MIDI to CV thing, because it seems like what I'm seeing here is the microcontroller works. When we send a MIDI signal to this device, the microcontroller flashes the LED to indicate that it is receiving a MIDI message, right? But the parameters of the MIDI message are such that it is unable, or it feels no need to try to communicate with the DAC, the 2 DACs. I use it with loop MIDI to control Ableton and send a message to my drum synth. Start talking about you talk to me about MIDI, it starts looking like these Node Red flows, and you're like, wait, what controls to that goes to that, and it goes around to this thing, and then that what? Wait a minute. So, not necessarily bad soldering, potentially just well, depending on how are they connected again? Hold on. Yeah, it goes direct, so it's just thing to thing. Technically, you should probably put a resistor in there just in case. But anyway, it's SPI communication, so it just goes directly back to the thing. So having nothing happening here seems to lead me to believe that it is the microcontroller does not feel the need to communicate, which means we are on the wrong channel, which means I need to make sure that I'm on the right bank and channel. So Erica, what is it? Erica MIDI? Yeah, Erica Synths. Erica Synths MIDI to CV2. No, I don't want to do that. Please just go directly to what I was doing. Oh, you son of a bitch. Erica Synths MIDI to CV2. There we go. Maybe Manuel. Schematics, component placement, assembly guide. No. PDF. Guide to assembly. MIDI CV. Here we go. Here we go. Here's all the information. Plus. Thank you for purchasing. Oh yeah, I was just delighted. MIDI output configuration in a mod output configuration mode. How do I know this? Connect MIDI keyboard to the module. Push program button for 4. MIDI LED will start to blink slowly. Select MIDI channel by pressing a key on the keyboard. Okay, this is what we did not do. So let's get this off of the. Let's put this back up on the test track. I also have a Steam Deck Plus, so I can turn pages with a swipe on the deck. Weird. Couldn't you just plug it in with USB and check what MIDI notes are coming out? I guess, but I need to know what this thing is set for. Listen, all this troubleshooting, doing all this troubleshooting in a particular way in order to isolate the problem. It's the whole purpose of troubleshooting, and it's become kind of intuitive for me, and I need to explain what exactly I'm doing more often. So troubleshooting is all about isolating the problem, and the problem is currently that this thing is not outputting anything. And if it's not outputting anything, what are the possible avenues that will prevent output from this device? Typically, on a DIY device like this, it's going to be my soldering somewhere, right? So I take the thing off and I check the voltage levels at the DAC, because we know that with MIDI coming in, this LED is flashing. By all means, we're probably on the wrong channel, but instead of checking that, I check to see if the microcontroller is trying to send data and the DACs are broken. So I look on the pins and I see a high voltage level, which means the microcontroller is asserting a high on those pins and just not attempting to communicate. There's no data going back and forth. There's no data going back and forth. Could the microcontroller be partially broken? That doesn't really happen. Usually the whole thing shits the bed all at once. So with no attempt at communication going on digitally, are the DACs broken? I don't know. They're not getting data. They would be getting data and not outputting, then it's the DACs. So those are fine, maybe. They're just off the table. MIDI's coming in, LED's flashing, microcontroller works. Microcontroller doesn't care to try to put an output signal on the line. Why? Wrong channel, wrong notes, wrong something. Looking at the manual, it appears the first thing that I read is setting a MIDI channel. So we didn't do that. So let's take a look at how we do that. Connect MIDI keyboard to the module, push program button for 4, MIDI LED will start to blink slowly. 1, 2, 3, 4. 1, 2, 3, 4. Blink slowly. Press the key on the keyboard. Double blink. And then it starts blinking again. Wait. Pushing a key on the keyboard. C of any octave corresponds to MIDI channel 1, C sharp channel 2, D channel 3. Channels 1 to 12 can be assigned to send MIDI messages to the module. What? For 2 MIDI channel configuration, push and hold 2 keys simultaneously. Wait, what else do I need to do? Push the program button to advance to mod output configuration. Huh? Mod output configuration mode. MIDI LED starts to blink faster. If you wish to assign a modulation wheel. Oh, that's kind of cool. Dude, modulation wheel we'll put on this one. If you wish to assign key velocity to the mod output, push any key on the keyboard. Oh, I want that actually. Push program button to confirm. Why do they spell it with 2 M's? And now we are 1 volt per octave calibration. That's good. I'll need that too. So now what happens? Because I just confirmed all that stuff that we just did. I should have shown you this view. If I hit a key on the keyboard, okay, nothing happens. We have it in CV gate 1, and we are in one note mode. Ugh, that was hard to say. Oh, but the probe is still connected to that one. Hold on, wait. Let's get the probe out of there and plug this one in. Yaha! Still nothing. Modulate doesn't do anything. All right, just check to see. Clock out probably won't be doing anything. This is still in the middle, yeah. Hitting buttons on the keys, hitting the keys. And then CV gate 2, CV gate 1 onto the channel 1. Oh, these Donkey Kongs need like a little breaking in period. Yeah, nothing doing on that channel. It may possibly still be my soldering. So use this knob to set, where are we? Use this knob to set the glide time on the output CV. It affects both channels simultaneously. The glide time. It's possible I need to zoom in too. All right, we're 1.5 volt. No, there's just nothing doing. We should be seeing a pretty confused controller. Yeah, you can map the mod wheel. It's pretty cool. I prefer to shit the bed all at once too. If you're gonna do it, you might as well not do it incrementally, yeah. Program button for 4 MIDI LED. What? I think they left out seconds. It would be nice if they told me that it was seconds there, because press channel for 4. Huh? So I guess, yeah, you hold it down for 1, 2, 3, 4. No, not long enough. 1 Mississippi, 2 Mississippi, 3. Oh, there it goes. So then it starts flashing. Select the MIDI channel by pushing a key on the keyboard. C of any octave corresponds to MIDI channel 1. C sharp channel 2. D channel 3. What? Wait, per note? C of any octave corresponds to MIDI channel 2. Oh man, keyboard keys. I need to bring this up just because it's been a long time, chat. It's been a long time. So my main man, C4, should be right there. So if I select C, it corresponds to MIDI channel 1, and we'll have to change the global channel. It has specific notes per channel. So either channel 1 or 2 by hitting this. Boop. So now we've assigned it channel 1 or 2. For 2 MIDI channel configuration, push and hold 2 keys simultaneously. CV gate 1 will be assigned to the lowest MIDI channel, CV gate 2 to the highest. Push the program button to advance to mod input. Okay, on to mod. And so for mod, I want to have that as velocity. So I hit any key. And then we're done. I'm starting to understand it a little bit better. So now I'm on global channel 0, so I'm going to change it to channel 1. So advanced, and then channel assign, go to channel 1 and hit enter. We're on channel 1. And so now if I play button, we get the voltage level from button. And voltage moves as I hit other button. Yes, yes, ha ha ha. We are now making the music. Welcome to Euro music. Okay, cool. Hey, this thing works now. I've got assignable burp 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 burp. Yeah, we're that much closer to the unts. This is a feature that should be built into this keyboard. The volt per note thing should just be a TRS plug on the back of this stupid thing. But I can get other MIDI controllers involved too. The Erica Synths one is not super featureful. You know, in the future, using Arduino, I could have a MIDI input and use like an Arduino, even like not TNC4 would be hugely overkill, but I could do like multiple voices. I could do like 8 or 9 plugs that would go to their own VCOs and have 8 or 9 voices on the thing. But because you know that thing doesn't do individual mode. But okay, so this is good because once I calibrate this, and there is a digital calibration, that's the next step on this thing, I will be able to actually use it to test things out. So mod should be velocity, right? Oh wait, CV gate 1 we want on channel 1 anyway. Channel 2 is going to be the velocity. Aha! Channel 2 is at 1.5 volts. Let's bump that up to 8 volts. Yeah, look at that. If I hit the key softly, it's 1 CV level, right? And I slam it, it goes all the way up to a possible 6 volts. Or no, I think that's 5 volts. Yeah, it's a 5 volt control signal. That's cool. Soft press. Very light. Yeah, depending on which one I release, because it gets 3 signals at once, and whichever one I, in the digital scheme of things, pressed first gets precedent, and it'll hold on that note. But this can be, you can assign the velocity to a like a gate or a what is it called again? Velocity, sustain, blah 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 blah. Cool. Okay, so that only took 3 hours and 32 minutes until we had a functional device and were able to do the somewhat complicated troubleshooting of getting to this. But you guys can see how I sort of intuit troubleshooting, and I'm actually good at it. ADSR, yeah, you'd send one into an ADSR or some kind of like a gate controller, and then the other one would go into the VCO. So the VCO would just hold on the note, but then the ADSR would use that input voltage to determine how it's going to handle the notes like how it comes in and how it goes out. With those two, with these two, I can control a VCO with a keyboard as if it were a note being hit on a keyboard. But I could also do all kinds of other crazy crap because it's a modular synthesizer and anything goes. Very cool, very cool, very cool, very cool, very cool. And in 2-voice mode, I can hit 2 buttons at once, although predominantly I would rather it have 3-voice mode so I can hit a whole chord. I also have a processor that I could populate. This is a Hajiwo design that uses a RPi, whatever that Pico processor thing. This is the Seed Studio version of that. It's a really nice little microcontroller platform, and it's fast, and it's able to go into what's called a Salin key filter in order to make a VCO. I have a version of this on a different PCB. I would have to do a little bit of editing down here because there's a mistake on the board, but if I were to get it working, it could be a chord VCO. So it would output something that sounds like a chord of different notes. I wouldn't be able to hit specific chords. It would just work like an arpeggiator, where if I send it a signal, it'll send out a chord. So it's a little different. It's probably more fun to utilize with something like a sequencer, or like an easy like CV output. But having it so that I could hit one key and hear a chord would be kind of neat too. That is so cool though. It separates the signals out. So you have the note, which is the yellow signal there, and then you have the attack, the velocity of how hard I've hit the button. So if I really slam it, or if I just gently press it. You'd have to put it into like a reverse. You'd have to invert this to use it in like an ADSR, so that would represent a real sudden like bang, and then that would be just like a cool. All right, well, we're gonna learn how to use this some other time. I'm gonna tune it on my own. There's a little tuning thing that you can go through, because electronics, again, are statistical probabilities. They are not all exactly what you're ordering unless you specify very tight tolerances in your resistors and stuff. What'll happen is the microcontroller, first of all, is not necessarily going to have exactly the right clock rate going into it. Its reference voltages might go through some weird steps, and they'll be off by a little bit. And then all the values that you chose for the output stuff, all the resistors and capacitors, are going to be 1 to 5% off of their original intended values. And so you might have it amplifying the signal too much, too little, et cetera, et cetera, et cetera. So you tune it. And I tune it with pretty heavy precision using the oscilloscope, which is the most accurate piece of equipment I have. In fact, it is just as accurate as the B&O Precision multimeter, the desk-mounted multimeter. One day, and not soon, unfortunately, yellow signal and brown note. Oh no. One day I will move shop. I'm very comfortable in this shop right now. If I could move it to a warehouse, like one of those little, like a 1-car garage, I could make a wall of equipment where I can have all of the blinking lights on at once. I've got a small collection of test equipment now. I've kind of always had a small collection of test equipment. The test equipment that you really want to hold on to is the stuff with a screen. I have an analog oscilloscope that we need to repair at some point, and all kinds of old scopes and things like that. I would love to get that on a wall and have that in the background so that there were blinking lights in the background. One day we'll be able to do that. But anyway, the oscilloscope is how I'm tuning stuff, and it goes down to the number of digits that the precision multimeter that I have goes to. So I might as well just use the scope to tune this thing, and then it'll be a precision piece of equipment that I can use with the rest of my synthesizer. Thank you for joining me on this unexpected final stream with this stupid MIDI to CD thing. I think it's a really cool little piece of equipment. I could get it running with 2 notes at the same time as well. We'll see where that goes, and I'll try to learn how to use it a little better in the future. But now what I can do is use this in conjunction with other modules as I learn how to put together a synthesizer, essentially, in modules. And we can, I don't think we're going to necessarily use this to tune the other modules, but I can figure out what other modules I need in the signal path and get to know them, get them calibrated, plug them in, and then I can use the keyboard to manipulate them. And that'll be a little better than having like a constant, 4-note sequence going into the thing during a whole stream. It'll be a little bit more dynamic and interesting as opposed to my friends who sit here with a sequence going beep, boop, beep, beep, boop, beep, beep, boop, beep for 10 hours. It's like torture. If ever I get a new scope, I'll flip the axis of one channel and use it as a stereo vector scope for my audio. That's the cool thing with the scopes, is that when you have an old scope, you can flip it into XY mode and have one channel do the X and the other do the Y, and it does the oscilloscope music effect. And it's more fun with a scope that does the electron beam vectoring. I have a digital scope that I can do that with too, but then it ends up having sort of a mess of a low quality like thing. But I've still got the old Rigol and the old Tektronix scope. Those are both LCD scopes. But a viewer sent in a nice little tube scope that is broken. There's something wrong with it. I would love to get in there and fix it. It's kind of dangerous to do, which makes it even more exciting. Anyway, I don't have the end card ready yet. Let me just do that real quick, and then we'll see if anybody else is around. I need to go touch Grassington to walk Walkie the dog because she's barking at the door. But this has been fun. I thank you guys for, the help. I mean, you guys have been helping. I try very hard to be polite, and the mask falls off, and I end up being totally rude to people whose only wish is to help me, and also to sound smart. I keep hitting this camera right here. Wait, it's not August 2nd. It's Seppo 2. We'll be back at Seppo 2. I have a doctor's appointment at Seppo 8 that I have to go to because it's super important, because it's my new primary care physician. That is on Monday. Okay, that's on a Monday in like 2 weeks. Okay, so I'll catch you guys on Tuesday next week, and we're going to get into something new. I don't know what. Not new, either old or LEDs or something like that. The computer stuff I may just start doing on my own, and then it's possible, and I don't think this is going to happen this week. Maybe it will. I got to pull apart the rack mount enclosure. I got to clean it. It's full of dust. I need to reorganize it, and I need to get it so that I've got the Focusrite on the other table and maybe a place to park the mixer in that setup, and be able to close the whole thing finally so that I can keep dust out of it. It's full of dust. And the water cooling is probably not as effective. I need to also look at the RAM on that thing and see if I can buy more RAM. I tried downloading RAM and it didn't work. It just didn't work. But that thing needs more RAM. We keep parking these Chrome tabs, and I need to move this thing off of Chrome. This is too much. So that could possibly be disruptive towards stream next week if I get the bug up my butt and decide to do it. I don't think I will, but it's on the horizon. Something's got to give, right? And I need to get a haircut. So I will catch you guys on Tuesday. Thank you so much for joining me, and we'll be back Tuesday. Unless, everything is exploded, but I'll let you guys know. Here's the end card. Why is Twitch notifying me of something? What is this? This notice is to let you know we are updating the monetized streamer agreement pursuant of Section 7 modification. You will be legally executed in order to save us on taxes. Oh, okay. All right. Well, maybe we won't stream next week. Okay, 38 viewers, and I'm ending the stream, and we're just going to pull the plug on it. I will see you guys on Tuesday. Check me out in Discord if you want to get in contact, and I'll